Windows?
No, that's,
Oh, interesting.
I can show you. I saved that error if you want.
Because I don't get enough error messages. No, it's not.
Just in case you
No, usually on Linux it builds easily because it's just some speed up extensions. It doesn't build on Windows because no one has Windows compilers installed.
How about a Mac? What happens on Mac?
It should install as well. You need to have Xcode
Okay.
installed, which almost everyone that what? It works fine. Good. It's not there. File's not found. Okay, so hi, Stuart. Nice to meet you.
Do you have a lunch ticket?
I should.
You shouldn't.
I shouldn't. Okay, then I don't have it.
Well, I mean, you should, but it didn't happen. So here.
Great. Thank you very much.
Do you need to use the email?
Any? No, it's all me. Thanks. Thank you. All right, so the link is not there, right? What is the PyCon network password? 2014. You all passed the test. Oh, I guess I have the password? That's. Oh, it's doing a thing? Oh, it does the thing? Do I have to go to a site to make it? Okay, and then what is it, PyCon 2014? What's the? Oh, that is the. Yeah, sorry. Yeah, it's going to be. Okay. Sorry. Fix that. Oh, sorry. That's your screen too. You got it? Okay. It's 7 meg. Well, it's got the whole, yeah. So who already uses SQLAlchemy? Who already has used it? Nobody? Everyone's a newbie? You've used it? So you guys have never used this thing, and okay, so you get the total low. All right. What's that? Right. Well, yeah. Sure, yeah. So there's 4 USBs, and if you want to use the USB instead, yeah, that's a terrible use that one. Does anybody wants USBs instead of, you want to use a USB? Here you go. People are getting installed, yeah. You don't. I mean, technically, if you install doesn't work, you still can enjoy the tutorial and do it later. It's just like what this has is a code thing that you can step through code as I step through it. And if we decide to do exercises, you can try to type them in. So who has managed to download the thing and get it to do something correct? One person, 2 people. Who is still trying to who is like downloading and it's taking a long time to download? You got yours? Which one? It should be, no, okay, so, all right, so here's the next thing is because you guys didn't get the email, I should have checked more on that. There's a script in there. Called install vm, and if you run that, it will make a little virtual env Well, here, there's the problem. Is that, again, I was hoping people did this ahead of time. It would need virtual env. That's the one library you need. Has everyone heard of virtual env? Everyone knows that. Okay. In previous years, people didn't always know that.
I just learned about it like 4 months ago.
Okay.
But anyway.
Yeah.
So is there like a test that I can run to make sure everything is all fine?
If it installed fine, you're probably fine. I mean, if you do this, if you type vn bin python, like that, can you guys see the bottom of the screen here? That's going to screw you up too, isn't it? Most of the slides will be at the middle of the screen, so that you won't have this problem. But so if you do that, that should run it, and you get that.
Yep, got it. Thanks.
Yeah. Yeah, it's just use the SQLite, which is part of the Python install. So the whole video, I'm going to be I'm going to be like this. No one can see me.
How does it feel wearing those headsets?
How's it feel? I like it better than having something here. Yeah, because, I can get it off and I don't know. So usually with this talk, I barely make it all the way through. And sometimes I talk really fast and then my throat gets destroyed. And because today I'm sick, I can't afford to do that. So maybe I'll talk slower, which would mean that we wouldn't get through everything. But I'm also really cloudy-headed, so I'll probably forget many details, and then maybe it'll go faster again. It's really no way to know where it's going to go. And, I try to prepare. It's like, you know what? The best thing is just to go there and wing it. I mean, I've done this talk 5 or 6 times, but it's been a while. Also, the previous year is of the same exact lecture is online. And I feel bad if people didn't know that. Like, you do get the bonus, I'm in the room with you. It's on the, well, it's not on this year's PyCon site. It's on the videos from last year's site. It's on my blog, and it's on the SQLAlchemy site itself nowadays. And it's free, because you didn't go. You weren't there. Well, is anyone here who went last year and just wants the repeat show? Nobody. Nobody came from. So who is still trying to install? Who has either installed it or has given up and just going to watch the show? You've installed. You understand that I've asked questions that cover everyone in the room, so everyone should have raised their hands to one of those questions at this point. And so no one's raising their hands. So the install, so what you want to do is you want to run here. You want to run, well, you have to have Python installed. Sorry, in case you didn't. Install VM. Let me go to a temp. Let me go to a temp directory. So what it looks like is you unzip it. You go Python install VM py, right? And install VM py will then run all that stuff. And then what you will have is a directory called dir. Haha, look at me. That's the call. Like, oh, you're in MS-DOS. You'll have a little VM directory, and you can say Python, and get a Python prompt. It's only 9:01, so we're not even behind yet. I could give like 5 more minutes for people to decide what they want to do in there. And then there's this a program called SLideREPL. That's what I'm going to run, and you can run it too. It's also a prompt. And there are 4 scripts that we'll be doing. Well, there's actually 6 of them, but there's 1, 2, 3, and 4. And then if I do this correctly, we'll get to 04 advanced. We're going to skip this one, because this one kind of covers the same thing in a different way. And then if you want to run one of those with the slide tool, you do VM bin slide REPL as though it were the Python interpreter, and with the script name, and you get this thing. And then if you press the return key, you'll get little code examples, and then they run like that. And this is, most of the talk is going to look like this, where I'm basically flipping through. And if you manage to get the software installed, then you can do the same thing on your computer. And if you didn't, it's not a big deal. Oh, right. This is the attendance. So now we will take it to it's the attendance sheet. Who didn't come to class? Okay. There's also a survey that I'm supposed to show you, and I didn't. Let me find that survey. The survey is. I don't have the survey. Is there? I'm not going to find the survey here, so let me get off of that. We'll get the survey later. I'll get it from Stuart. There's a link to a SurveyMonkey survey where you say, did you enjoy arriving at PyCon 2014 tutorials? All right, so SQLAlchemy is, it has to do with relational databases, right? And relational databases, as opposed to your garden variety NoSQL database, features this language called SQL. Everyone's heard of SQL, right? Everyone has. So has everyone kind of dealt with SQL at a very rudimentary select star from table? Select star from table. Let's hear it for, okay. How about insert into table? Everyone knows insert create table. Okay, so you know what that means. So what we're doing with that is you have maybe a command prompt to a database, to your Postgres, and then you type these commands, and they're just commands, and they go to the back end, and the back end interprets them. And if you say create table, it'll make a table, which is kind of like this thing that holds rows, right? Non-mysterious, right? Okay, so SQLAlchemy kind of is this tool that really all it's doing, this is the most reductionist way of talking about it, is it creates strings to send to the database. And it gets strings back. It's really all it is. Some people, sometimes people think it's doing this more magical things than it's really capable of. It's really just a way of composing messages, right? Not a big deal, except it took me 10 years to write it. So let's see what the slides say, so that I can cruise for a while. Prerequisite knowledge, and this is another thing that I do, is that I will, because I don't have the slides memorized, I tend to talk ahead of them, because my brain will go to the next thing on my mind before I do the slide. And then I'll say, let's see what the slide says. It'll say basically what I just said, because I haven't worked that out. So this tutorial assumes basic knowledge about SQL, and importance, structure, what a table is, column, create table, how to query rows with select, how to modify data with insert, update, delete. To a lesser degree, if you know what a join is, everyone knows what a join is. Grouping. I used relational databases since about 1996, and I probably didn't know what a join was for 2 years, because back in the 90s, we didn't have as much wherewithal to, we didn't have big data back then. We didn't need joins. We had just a straight up. Anyway, it's never too late to learn what a join is. Okay. Transactions. SQLAlchemy is really hardcore about transactions in that we really kind of make you aware of them, and you kind of don't have an excuse to not be aware of transactions. And even if you're not using transactions, we kind of make you aware of that you're using autocommit. So people know what a transaction is, sort of. It's like you start something, and then it's kind of this little window of container of things you're doing, and then when you commit it, everything that you did in the transaction actually happens, right? It's actually way more complicated than that. And then also within transactions, this is not as obvious, is that there's this concept of isolation. Has anyone heard of transaction isolation? Okay, transaction isolation means when you have more than one transaction happening on a database, like if you have two MySQL connections, one transaction could be doing something, and what that transaction is doing may or may not be visible to another transaction. Like if you're in a transaction, you say insert some rows. What happens if the other transaction queries for those rows? Is the other transaction going to see them even though they haven't been committed yet? And it depends upon the isolation model that the backend is using. So isolation has to do with how different transactions see the ongoing work of each other. And SQLAlchemy has some design decisions made to deal with that. So an overview of this wonderful library. It says on the website, the database toolkit for Python. And first introduced 2005, the first release. Presents an end-to-end system for working with the Python database API, relational databases, and the SQL language. And we're up to 0.94. And we're going to do 1.0. Will be the next major version. And we counted all the way from 0.1, 0.2, 0.3. I think it took that long. It took that long to do it. The 1.0 will be done, and then I'm going on vacation. So what are the goals of SQLAlchemy? So provide helpers, tools, components to assist and automate database development at every level. Provide what's called a facade over the Python database API. A facade means that you take some API that does something in kind of a screwy way, and the facade kind of presents this, just do this and that, and it's done. That's kind of a really, again, reductionist. Reductionist means I'm oversimplifying the crap out of it. A, because I don't have the energy to go into it, and B, because I'm actually not that deeply aware of how things work. I just know I'm somewhat of a generalist in some ways. Provide industrial strength but optional object relational mapper, or ORM for short. And act as the foundation for any number of third-party or in-house tools. Philosophies. So bring the usage of different databases and database adapters like the Postgres adapter, the MySQL adapter, the Oracle adapter, the SQL Server adapter, to all be into this single interface that's as consistent as possible. Like you can deal with each of those databases without changing what your code looks like, but still expose the distinct behaviors and features of each backend. Which means that if SQL Server has some special thing that it does, or Postgres has some special thing that it does, and there are many, many special things that every database does, no exceptions, we still want you to be able to use that as well. Which means if you write your program with SQLAlchemy, you don't necessarily get a program that will automatically run on every database. You get a program that will pretty easily run on other databases, but might have some things that you're doing that are specific to that database. And if you want to make your program run on 3 different databases, you probably have to test it and kind of tweak it to make sure it does all 3. So SQLAlchemy is an abstraction layer over database APIs to the degree that it makes it very possible to write a multi-database application, but it doesn't make it automatic. It's not like you're using some other kind of abstraction that just hits every kind of backend with no changes, because that's not really realistic. Even tools that claim to do that can't really do that, because this goes into this philosophical debate, which is too much for here. It's called the leaky abstraction. You heard of that, leaky abstraction? All abstractions are leaky. If you're working with TCP, you might get an error message that's actually the IP layer, leaky abstraction. So you can't win. So SQLAlchemy doesn't try to win, and there you have it. And to that end, we don't really hide the database. We don't pretend that there's no database there. We don't say, hey, you can talk to MySQL or Postgres or MongoDB. We don't do that, because MongoDB is totally different from a relational database. So we don't hide it. You know, you're going to know when you work with SQLAlchemy, you have to know about joins. You have to understand that this thing creates tables. You know, it really works the best when you know what the database is doing in general. That's why I asked, does everyone know that you send a message to the database to create a table? Like, that's so awesome, because people will sometimes come to SQLAlchemy and not know that stuff. And then they're asking me questions, and they don't understand the general interaction. But not this crowd. So instead of hiding it, we just provide automation. So, you know, instead of having to do the same drudgery of typing insert into table, SQLAlchemy will provide a lot of patterns to automate that and help you to not have to really type so much. dry is don't repeat yourself. Heard of that? Fundamental computer thing. I am sick, just so you all know. I'm like this, so I'm just going to riff on it. Allow expression of database SQL tasks using declarative patterns, which just means it looks nice. We'll do more of that later. This is the. Has anyone ever looked at the SQLAlchemy documentation on the website? Have read the docs, looked around? So if you, this is probably on the intro page, I think, without the color. This is called a pancake diagram. I'm going really slow. We're not going to make it to the end, but I hope you'll all enjoy it anyway. The pancake diagram means that you have the different layers on top of each other that express things. So you know you have your database, and then Python provides this thing called the DBAPI, which is like you download that from pip, like PsychoPG2 is a DBAPI, and CX Oracle and PyODBC. These are other packages that do the low-level talking to the database. SQLAlchemy then has this thing called a dialect that kind of interprets instructions to the DBAPI. It has a connection pooling system that handles connecting to this, and then those are underneath this thing called the engine, which is the part that you'll kind of work with in the first chapter of this thing. And then you have two other things that work with the engine, being able to write SQL expressions and the system of dealing with schemas, tables, data types. And then after all that, this is all called the SQLAlchemy core. After that, then you have this thing called the ORM, which is up there. And you don't have to use the ORM if you work at Reddit. Reddit uses just this. If you work at Dropbox, they use just this. They hate the ORM. They hate it. So, and that was intentional. The ORM, I knew people wouldn't like it, so, or a lot of people wouldn't like it. So it's separate. So this is, again, this slide's going to basically repeat what I just said. The engine's registry to provide connectivity to a particular database. The dialect interprets generic SQL and database commands. The connection pool holds a connection of database connections for fast reuse. It also handles just like the lifespan of a connection. Like if a connection drops and has to reconnect, it does things like that too. SQL expression language, which you'll see allows us to write SQL using Python expressions. And the schema type system uses Python objects to represent tables, columns, and data types. Everyone cool so far? The ORM object relational mapper allows construction of Python objects which can be mapped to relational database tables. It persists objects into their corresponding tables using a pattern called unit of work, which hopefully we'll get to. Provides a query system, loading objects and attributes using SQL. You'll see what that looks like. Builds on top of the core. So the ORM doesn't actually write any SQL. It only composes core SQL expression constructs, which then become SQL. And we like to say the ORM presents like an object-centric perspective to your data as opposed to a schema-centric perspective, which the core, it's more about your objects rather than this table, this insert. And this is a great chart I stole from someone else. Someone else did a SQLAlchemy tutorial called SQLAlchemy is like an onion. And I think it's great. So some of you might have noticed there's kind of a color scheme going on. So we'll see the green. There's basically four parts to the talk, and then the four colors are kind of color-coded. Object relational mapping is kind of the outermost layer. So when SQLAlchemy when you first learn it from the inside out, which is what we're going to do, and also when I wrote SQLAlchemy, we started with just this, being able to talk to the database, and then dealing with how to create tables, get schema information, then how to deal with SQL expressions, and then finally, once we had the whole SQL toolkit, then we wrote the object relational mapper on top of that. And then you have the green Python Database API. So everyone know what a PEP is? Python Enhancement Proposal. That's where Python has all of its specifications for everything that it does. So DBAPI is PEP 249. So that's the system that pretty much everyone uses for providing Python database interfaces. There's many of them, many dozens of them. Most databases have more than one. MySQL has at least 10. And we support about 6 of them because people keep sending me pull requests. And they're completely all different in many ways. They're just so different. The DBAPI is a very casual spec. But you don't have to worry because I'm here. So the DBAPI if you were to use the DBAPI directly, which I think you should know how to do, because I will often have, when people give me report problems for me, I'll often have them do this. Because there'll be some problem, something that actually doesn't work with their DBAPI directly, so I'll have them test it at that level. It's really good to know what that means. So this is an example of the PsychoPG2 database API, which is for the Postgres database. It's a very good, it's the best, it's my favorite DBAPI, PsychoPG2. Using a DBAPI, there's always a connect function. The arguments that the connect function takes are dependent on the system you're using. They might be different. It might be an ODBC DSN, could be a file. Most of them have some combination of username, password, and some kind of host or something. Anyway, assuming you've got through connect, you get this thing called a connection. And that represents an actual TCP connection to a database backend, or in the case of SQLite, an open file handle. So once you have your connection, you want to actually do something with tables and rows, you have to do, well, you don't have to, but in the standard, in the spec, you create what's called a cursor. So a cursor in database parlance is this object that kind of knows how to flip through rows. I think that's kind of where it comes from. You say, hey, Mr. Cursor, execute this SQL statement. The database API has a system for using what's called bound parameters. A bound parameter means that you write your SQL as a string, but the parts that represent like data, specifically the stuff that you get from your login form on your web page or whatever, you don't put them in your string. Is this familiar to people? This is a pretty familiar concept. You instead put this placeholder, and then you put the value down here. And then the database API, PsychoPG2, is responsible for making sure this number 5 is rendered correctly when it goes to the database. Some systems actually don't even escape this. Like if you're using Oracle, Oracle actually has a low-level implementation called OCI, which actually has the CX Oracle database API sending along the values separately, and the server actually does the interpolation. So you can't assume that the DB API is doing the interpolation in the Python side. It actually what could happen on the server side. I have a lot of arguments with people I'm trying to get them to understand this bind parameter thing. It's a really big deal. So once you've executed your statement, you can say fetch a row. A row is like a Python tuple, like indexed pieces of data in a parenthesis thing, syntactically. So here's where we're saying empid emp name. So emp name is the first element. Close your cursor, and then maybe make another cursor, do another statement, close it. So this is what the DB API looks like. And this is what you don't use directly when SQLAlchemy does this work for you. Important DB API facts. The DB API assumes that a transaction is always in progress. When you make that connection, when we connected before, when we say connection equals connect, we're now, the first statements you execute, there's an implicit begin of a transaction. There's ways to turn that off in different DB APIs, but it's not part of the standard. So there's always a transaction that starts, and you have to say commit in order for the transaction to be committed. Water time. The DB API encourages bound parameters, the parameters I just showed you. But it has 6 different formats for no good reason at all. No good reason, and everyone on the DB API list knows we have to change it, but no one's doing it. DB APIs have inconsistencies regarding data types, primary keys. Pretty much everything is inconsistent on DB APIs. They're completely painful to code to. And it has its own exception hierarchy, which SQLAlchemy exposes directly in a generic namespace, and maybe we'll see what that means later. It's not that critical. So SQLAlchemy, the DB API. The first layer in SQLAlchemy is known as the engine, which is the object that maintains the classical DB API interaction. And we can finally go to our first slide REPL thing. Close that down. VM. So I'm going to run that, and that --pres just means it'll clear the screen before each slide, and you don't have to do that, or it doesn't matter. It'll make it so that my slides will be at the top of the screen so you can all see them. So this engine thing we're talking about, which is kind of this front end over the database API, we use one SQLAlchemy function called createEngine. And the sample here is going to use SQLite because SQLite is just kind of built in to Python. It's really easy to work with. So there's no actual TCP connection here. It'll just use SQLite. And this was going to make open up a SQLite database in a local file in the current directory called sum.db. And when you see this, this is actually a Python shell. This actually has run. So the engine is now assigned. However, we haven't actually connected to the database. Nothing's actually happened. The engine is just kind of, so far, just a container for that URL. It doesn't know anything about that database yet. It has what's called a lazy initialization pattern. And you know what I mean by lazy in computers? It means that don't do this until you definitely have to do it. Don't do it earlier, do it later. SQLAlchemy does a lot of lazy stuff like that, which can sometimes be problematic because sometimes people will have a connection problem, but it doesn't happen there, and they'll assume that's where the problem would have been, and it's not there, and they get confused. So we have this engine. What's the next slide going to say? Oh, the next slide is actually going to run something. Okay, great. So engine, the most bare bones way to use it, and this is really not how you usually use it, but this is the absolutely simplest way, is just engine execute a statement. That's the simplest thing you can possibly do. And when I press return, it'll run the code, and then what'll happen, so there's a little bit of stuff here. When the engine very first connects to the database for the first time, it needs to learn some things about the back end. And one of the things it does is it wants to see how this back end is dealing with Unicode. So the reason you'll see these two statements with the SQLite database every time we make a brand new engine and connect for the first time. And then for the rest of this slide, you won't see these anymore. The statement here is actually this one here. Like if we were to run it again, you wouldn't see that select cast stuff. This is actually going to screw up my slides. So if I just do that, you just see that again. And it's not a big deal. So far, pretty simple. So what that execute method gave us is a result object. Has methods that look like a DBAPI cursor, like fetch1, fetch all. The row itself looks like a Python tuple. You know, there's two columns in it. It also acts like a dictionary, which is an extension to what the normal cursor would give you, meaning the names of the columns that were in your select statement become keys in the dictionary that you get down there. So far, so good? Confusion? Good. The result will close when all the rows are exhausted, but we can also close it explicitly, which means that there's that DBAPI cursor is actually in that result object. You want to close that cursor, so the result close will close the cursor. And in this case, it will actually also return the connection that we were working with in the engine, but that's probably too much detail for now. You don't have to call result.close if you fetch the result fully. It automatically closes in as many cases as it knows. Result objects can be iterated. We can say select star from employee and go for row and result, print row, and you'll get the 3 rows that we have in the table right now. You can do fetch all, same thing. Gives you a list of rows, same thing. This is kind of like the Python DBAPI itself. Yeah.
So it just sounds like it's the convention when you're using SQLAlchemy to, when you're running a query, just assign it as something called result. Like, is that or is that just a variable you have?
I think, well, if I write code just to test something quick, I might call it R. Result is a nice name. You know, you want to have your variables named nicely, so result is a good name.
Yeah, I understand that.
Because the result is a collection of rows. You could say rows, maybe, although the result is more than just rows. There's other information. So I don't know that it's a convention, but I mean, obviously I have my own conventions, which are result, engine, and then when I write code to test, I will use R and E, which probably are not good for general use, but when I just type, I just want to type engine. So yeah. We can insert employee to the month. Yep. as the dictionary. Well, let's see if we can get the result here. So result has so there's the row, and it looks like that. It has keys, and it has row emp name. The way that works is that there's oh, it's not. It's what is it called? I'm not going to remember my own code's name. Oh, it's in the result. All right. The original result that we got, all right, yeah, so this is the result. The actual DBAPI cursor is actually right there as result.cursor. Yeah, the cursor's in it. Yeah, okay, see, good. I'm glad that helps people understand. The DBAPI cursor has this thing called description, which has the names in it in order. So in a very simplistic way, that's how we're getting those keys. It actually does much more crazy things later when we use the core expression language. This is like the most simple layer of things. But at the most fundamental level, it uses description to get those names. Now we've worked with engine.execute. So what that doesn't really tell us is where are we actually using a connection resource to the database, because we might have 5 connections open. How do we know where those connections are? The next level of using the engine is to actually connect. You get this wrapper called a connection. Excuse me. And so as you get the connection, this is not the DBAPI connection. This is a SQLAlchemy connection, which wraps the DBAPI connection object the same way that the result wraps the cursor. So, oops, I'm going to knock the screen over to just keep hitting that thing like that for whatever reason. Result equals connection execute. Give me the rows from employee, fetch them, and then we can close the connection. When I do this, it'll do all that stuff. And it's the same thing, but different way of doing it. Meaning that when we have this connection, we can run multiple statements on that one connection, and we know if we look at our TCP connections to Postgres, we'll see just that one connection, as opposed to engine execute trying to connect each time. To run several statements inside a transaction, connection features a begin method that returns a transaction. So you can connect, and you can say trans equals con begin, do some stuff, and then commit the transaction. Now, if you notice from earlier, I said that the Python database API is always in a transaction. And what that means is that SQLAlchemy's connection, when you don't use this begin, actually will emit a commit automatically after each insert, update, or delete statement, which is called auto commit. So it's probably confusing when you first see this for the first time. It's really not that confusing. SQLAlchemy's connection and engine are what's called auto committing. So any statement that you run that modifies the database will be committed at once, which is kind of what I think most people expect. Like when you run like with MySQL or Postgres, if you just log in, your statements are auto commit by default. That's kind of what people usually expect. When I wrote SQLAlchemy, I kind of made it act auto commit, even though the Python DBAPI is not auto commit. I flipped it around, and that's how it works. So if you want to actually have a transaction with multiple things happening, so basically when you say begin, that turns off the auto commit. And then does this, and then you do the commit, and then it does the DBAPI level commit, and then this begin is over, and then we're back into auto commit mode again, but then we just close it. So what you'll see when we run this, it'll show you, oh, here I'm beginning, now I'm doing this, now I'm doing that, now I'm committing. It has this weird word after begin called implicit. The reason it says implicit is because the DBAPI itself doesn't have a begin method. SQLAlchemy didn't actually do anything to do the begin. It just started doing stuff. And then it has the commit. So we say begin. We didn't always used to say this, but we say it now just so people can see this is where SQLAlchemy decided that you had said begin to start doing things in a transaction. So is everyone confused now? Just the first chapter, I've already confused you all. It's not so terrible. The same code we just saw, you can do it like this using a Python context manager, which is the with statement. I wrote SQLAlchemy back when we were at Python 2.3. So we had 2 major releases before this existed. We would have been much better integrated with this from day one if it had existed, but it was Python 2.3. And with, I think context didn't come until 2.5. Something like that. All right. So what this does is this will do the whole begin and commit for you. So begin. So at this point, you should at least see this is a lot more succinct than the DBAPI thing I showed you before, right? It's a lot less code. That's automation. So we know what it's doing. We know how the DBAPI works. It's not like this is it's not like this is making us not have to worry about what it's doing, but it automates us having to deal with all that boilerplate code. Yes. Great.
I think I'm not quite clear on whether this is just using SQLAlchemy core or also the ORM.
We're completely in the very bottom of core.
I thought so.
And I'm going really slow, and I hope we can get through core before the break.
All right, thanks. I thought so. I just wanted to check.
Yeah. Oh, is the break at 10:30 is what I'm clocking to here? Does anyone know? Is it on the schedule? Sounds good? That's the lunch. Previously, they would say that there's a break in the middle of the tutorial. So I guess, yeah, there used to be snacks, but I guess, okay. Well, I want you to get the snacks, so that's why I'm asking about the 10:30. Oh, an exercise. I haven't figured out how to do exercises with a group because a lot of times people are like, exercise is, but then I don't want to blow through it. So I have this approach, which is where I start doing the exercise myself up here, and you can watch me, and then you can either try to beat me if you think it's easy, or you can. And also, it tests me on being able to actually think in front of an audience, which I find very difficult to do. So what this is, this database, this program has already made this table for us. We're going to insert Dilbert. Oh, so we're going to insert a row with emp name equals Dilbert, but we're not going to include the emp ID column because SQLite will generate that for us, and you'll see what it looks like. And then we're going to select all rows, and we're just going to use engine execute. So this is where that insert into and also, I didn't cover this formally. With the SQLite database, we're using the colon style of named parameter. There's actually 6 different styles. At this level, when you use engine execute, the bound parameter format is whatever the DBAPI uses. SQLAlchemy is not it is not processing those yet. It will later, but at this level, you have to do what the SQLite DBAPI expects. Anybody finished? The trace you see here, the engine has a setting called echo. I think that'll turn it off. Okay, so what's happening here, there's an echo setting, but what this echo is doing is actually using Python logging. And then this runner thing is actually setting up a special logger to do that. So it's basically Python logging. If you ran, if you just did this, VM. This will say nothing. If I do that, then you get that. So that's the echo, and echo is a shortcut for setting up Python logging. I'm just going back, I'm trying to remember the command to go back to the slide. I forgot how this works. Let me do this again. Question mark for help. Okay. Oh, exclamation point. G. 13. When you write enough code, you will no longer know how your own code works. All right, so this is just basically regurgitating what we just did. So engine execute, I think we've got the general idea. Maybe not the auto commit thing. It's okay. It's only an intro. So we'll do the next color. Okay, cool. No one's bewildered. Okay, good. Oh, but first we have some engine facts. Executing via the engine is called connectionless execution. So when we said engine.execute, you don't actually see any connection being dealt with. There is a connection in the background, of course, but from your perspective, you don't see a connection. So we call that in the docs connectionless execution, meaning you're just executing without having to deal with a connection object. Using a connection is called explicit execution. We control the span of a database connection in use. Engine usually uses a connection pool, which means disconnecting. If you say like connection.close, it doesn't actually close the connection. It'll just return the connection to the connection pool. There's no need to get too deep into that. Just the basic idea. The SQL we send to engine.execute as a string. Other ways it's different, but as the raw string, it isn't modified. It's sent to the database API verbatim as it is, without any change to the bind parameter format. So whatever quirks that the DB API has, you can send those to engine execute. And that's like that so that people can work with the DB API in a very direct way if there's some weird command that it does that SQLAlchemy doesn't like to do. That should be the end of engine. Yes. Okay, so the next level is the table, metadata, reflection, and DDL. DDL is a subset of SQL that stands for Data Definition Language. DDL is most commonly recognized as the create table statement is probably the most common. DDL and drop table, create sequence, drop sequence, alter table, alter a column, create constraint, all that stuff is DDL. It's kind of the language that we use to alter the schema and of the database, as opposed to working with the data in the database. And what is metadata? So it's popularized by Martin Fowler, and I learned it from a book that he wrote called Patterns of Enterprise Architecture. SQLAlchemy is very influenced by that book. Describes the structure of the database. So when we talk about SQLAlchemy metadata, it describes the tables, columns, constraints, and everything else in terms of Python data structure. So we're going to make an object in Python that represents a table. It's basically like a little mirror of a table as it exists in your database. And in the Python world, we can then talk about a certain table in your database by having this object that refers to it. So these database metadata serves as the basis for generating SQL statements. It's the basis for object relational mapping. When you have metadata describing a database schema, you can use it to generate create statements or drop statements. If you have like 3 table objects, you can say create table. It'll emit those statements for you and format the structure of the create table statement. And you can also generate Python level metadata from an existing database schema. And that's called reflection or introspection. So if you have like a MySQL database that's already there, you can connect SQLAlchemy to it and pull in all the table structures into your program as Python objects that you can then map to. You can make SQL statements around them, and we do a lot with that. And both are widely used. And with that, we go to the next slide, REPL. And then we have our first example of what SQLAlchemy database metadata looks like. So we have a lot of imports here. I think what most people do is they say import SQLAlchemy as SA or something like that. SA is kind of a convention. No, I didn't. It's just one that people decided on. And then you'll see a lot of SA.table, SA.column, which is fine. When I type examples, I tend to just do from SQLAlchemy import star because I'm only working with SQLAlchemy. And as we know, import star is a bad habit, so don't do it. But that's why I don't have it here. But if I was just doing this on my own, I would just say from SQLAlchemy import star, so I have the least amount of typing possible because it's just a one-off. In a real app, I will do something like this, or I'll do. I tend to do this. I tend to have each symbol directly there as the thing I want. But you can also, if you don't want to type all these imports, you could say import SQLAlchemy as SA and SA dot everything. I see that all the time. So what we have here is, this has nothing to do with there's no database connection here. There's nothing to do with any database of any kind. This is just a Python object called a table. And we just constructed this table and gave it 1, 2, 3, 4, 5 arguments. The first argument is the name of the table. The second argument is this object called the metadata, which most of what you do with metadata is just that. You just make it, and it's just sitting there. It's basically a container for tables. Every table that we create that has this metadata will basically populate itself into the metadata as part of its collection of tables. A table of a given name can only exist once within that metadata object. And we can make tables that refer to each other using foreign key constraints by name. And the metadata object serves as a place that it can look up those other tables by name. And then we'll see later that the metadata is also a place where we can emit commands like create all the tables, drop all the tables. And that's about it. So the Python table is represented as the table object. The columns within it are represented using objects called columns. Each column has a name, and you can also give each column, you have to actually, give each column a data type, like integer or string. On the database, string is usually a varchar. Those of you who've worked with databases have seen varchar before. It's the character type. All right, so nothing has happened with the data. This is just a Python object. The table provides a single point of information regarding the structure of a table and a schema. So we can ask this table that we just made for what its name is. The name is user. There's an attribute on the table called C. It's an associative array, meaning it's not quite a Python dictionary. It's kind of like a dictionary. Like that. Has keys on it. The .c collection is where all the columns that we created are accessible by name. You can also do this. You can also, if you have a funny name or dynamic name, do that. The C collection is a bit like a Python dictionary, but not totally. So then once we're in the .c collection and we say user table.c.name, that's an object called a user. I'll show you that again. Is the column object within the table. So that itself has a name field, which is, in this case, name. I'm assuming there's an ID column. There's always an ID. Yeah, ID. It has a type, which shows what kind of type it is. So name, the name column's type is string. This is okay? Is that right? Good. Let's speed up. Table has other information available, such as a collection of columns which comprise the table's primary key. It's called .primary key. It shows you what tables are part of the PK. The table object is at the core of the SQL expression system. And there'll be another set of slides that shows you that. But this is basically the idea is that if you have this table object, you could say, hey, table object, dot select. And it'll give you that. And you can also say where user table.c full name equals blah, like that. If I get the syntax right, it'll give me that. So that's a sneak peek of the SQL core expression language. So it builds off of the metadata. Remember the onion. SQL is around the metadata system. So let's actually put the two things together. Let's make an engine like we did before. And then let's send the engine to this special command on metadata called create all. So say, hey, metadata, we know you have this table object. Why don't you make create statements for all the tables you have to this engine that we're going to give you? And here's where you can see it really saving us time versus raw DBAPI. So we run that code, and we get the same old embarrassing Unicode test I told you to ignore. And then the dialect will, by default, check to see if the table's already there. So it won't create it if it's already there. In SQLite, it uses this command called pragma. In MySQL, it'll query the information schema or whatever. And then it emits the create table to the database. And you can see this is just one SQL statement, because you see SQL is where the statement starts, and this is where it ends. So you can see there's that. And then there's a commit. Some databases have what's called transactional DDL, which means that when you create a bunch of tables, you can do that inside of a transaction. And if you don't commit the transaction, the tables don't get created. So SQLAlchemy will emit a commit after each create table. And you actually can also do transactional DDL if the database supports it, which means that you can have a whole schema, create the whole thing, and then insert data, and then, oh, I made a mistake, and you roll the whole thing back, and all the tables are gone. And we use that. We use that with database migrations. That's an important feature. I think SQLite has transactional DDL, but the SQLite Python driver breaks it. So with SQLite, we don't have transactional DDL until they fix a bug in the PySQLite driver. So a little bit on data types. This just is another table that we're going to call fancy, because this table thinks it's all fancy. And we're going to have table, metadata, and the column, usual stuff. But now I have some fancy data types. So, the string type obviously can take a length, because varchar usually has a length. A date time type, a precision numeric. This is a precision because it has a precision and a scale setting, meaning that the database, if it is worth its salt, will store numerics of 10 digits and 2 places past the decimal point with perfect accuracy, not floating point shenanigans. And we have an enum, which means that this type can be any of A, B, or C, but not anything else. And SQLite doesn't have any num type, so you'll see all kinds of fanciness happen when we create the table. So, well, first of all, key is a reserved word, so it has to quote it. So that just saved us that trouble. The varchar 50 had a date time type. SQLite actually doesn't really have data types per se. It has this thing called type affinities. Has anyone ever heard of a type affinity in SQLite? I advise you don't hear of it. No, it has a really goofy type system, but it looks like type. So just assume it's a regular type. And SQLite is actually not quite what you see, but it's close enough. The amount, date is the numeric. And then there's our enum. And then SQLAlchemy, because SQLite doesn't have an enumerated type, it actually added a check constraint to make sure that this varchar is in one of these 3 values. Right? Makes sense to some degree? Those are fancy types. Table metadata also allows for constraints and indexes, which is kind of a very critical feature. So we make another table that will refer to the user table that we made up in the first slide there, using a construct that we will import called foreign key. Foreign key is a single column foreign key constraint. So that means that if we have a foreign key that is only going to encompass one column and refer to one typically primary key column, we can use foreign key. If we have a composite foreign key, we will use something else in the next slide. Foreign key, so we can say, hey, address, make a foreign key to the user table. Foreign key lets us optionally specify, and you most of the time, specify the target table using a string. So with this string, the SQLAlchemy will take that string, go into the metadata object, and find the other table with the name user. And that's how it will figure out to link those together. And the reason strings are handy is because we can make the address table first, and then we can declare the user table second. And this won't break. So you can actually declare the address table before the one that it's dependent on. If we were doing SQL by hand, you would definitely have to make the user table first before we can make the foreign key constraint to the user, because you can't make a constraint to a table that doesn't exist yet. So SQLAlchemy is kind of helping us by letting us declare the tables in whatever order we want. And only when we actually do something important like create all does it need to have both address and user be present. Does that sort of make sense? Good. All right. So we'll ask it to individually create address. We could say metadata create all again if we wanted to. This will illustrate just a single create of a single table. Create table address, blah, 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 and then there's your constraint. It's on the user ID column, refers to the user table ID column. Commit. This is a composite foreign key. It's more verbose. A composite foreign key is when we have a foreign key constraint that has more than one column in it. And typically, the composite foreign key is used when we have a table with a composite primary key. And a composite primary key means that our primary key encompasses more than one column. Everyone knows that, right? Okay. So here we have a table called story, and it's primary key, but then each story also has a version. So the primary key, so you notice when we make a composite primary key, we don't have to do primary key constraint. We could, if we just flag both the columns as primary key, that's enough for SQLAlchemy to know that the composite primary key is these two columns. And then when we make the foreign key constraint, we just list out both columns from the local table here, story ID and version ID, will both refer to the remote column in the story table. Yeah. Now, the reason table and column metadata looks like this is because I tried to make it resemble what it looks like when you type the create table statements. So that's why it looks the way it looks. It's trying to look as much like real DDL as possible, and that's why foreign key constraint works that way with the two lists of columns. That's kind of how it works in DDL. So it's kind of emulating that style. Maybe there were other styles that might have been better, but that's what we have. And once you've got your API, it's really hard to change it or add an alternate. Adding alternate APIs is really hard because now you have two ways to do the same thing and people are confused. So if you want to have two ways to do the same thing, you have to really be sure you want to do it like that. So anyway, we have foreign key constraint like that. And we can create those tables, and this will actually show, we'll do create all. And what that'll do is if I scroll up, you'll see that it did a pragma for every table and figured out, okay, this is not there, this is not there, this is there, this is not, this is there, this is there, this is not there. So it knew we had just this and this to create. And it also figured out, based on the dependencies of these two tables, it knows that published is dependent on story because there's a foreign key here. So it knows to make story first. Now it could also make the two tables that do the constraint later. It doesn't. Could have. It can do that if you wanted to. It doesn't do that by default. But by default, it'll just create the tables in order of dependency. If you have tables with mutual dependencies, then you have to use that setting that does the foreign keys separately. Okay. Let's see what the time is. And assuming I want to get through core by 10:30, I want to get through half of core by 10:30. Let's do that. That way we can go a little slower. So this is an exercise, and what does this exercise want us to do? Make a table. And then these are the imports. Okay. And then emit create all, which will emit the create. It'll skip those 06. All right. Okay. This one's hard to type in because it's a lot of parentheses, and if you type it wrong, you're in the Python shell. And also, yeah, nullable equals false means not null. Column is nullable by default. So again, it's a restatement of what we just did. These exercises are pretty regurgitory. Is that a word? Regurgitory, should be a word. So network, bunch of columns. Owner ID refers to user ID. It's the owner of the network, whatever that means. Foreign key, user.id, so you get the table. It checks for all the tables. They're all there except for network, creates network. The default type. Does, oh, right. Yeah, sorry. I made a trick. I did a trick there. Sorry. But good. Right. So, okay. This is a feature that we've always had, but it really worked like crap up until version 8. Maybe version 9. I finally fixed it that it doesn't make a mistake. Is that if you have a foreign key, you can omit the type because that can be inferred from the what it's pointing to. It always had that feature, but for a long time it was easily fooled. If you made the tables in the wrong order, it would get confused, and people had problems. So I said, for years, just don't use it, it doesn't work. And finally, I got it to work one day. After SQLAlchemy added a much more comprehensive event model, there's an event model that, like, whenever you build things, there's all these events firing off. It works now. So yeah, so now I do that, and it's very convenient. So yeah, you can omit the type. If you put the type there, you still get 100. Still get an A. Because I didn't tell you. I didn't realize I did it like that. All right, so much for that exercise. I think that was pretty straightforward. Now here's where people start using this a lot. People love this. Reflection refers to loading a table object based on what it reads from an existing database. So conveniently enough, as we go through these slides, we actually have an existing database because we just built up a database with about 6 or 7 tables in it. And the metadata object we've been working with has those table objects fully formed within it. We want to illustrate what it looks like to reflect those tables from an existing database. So for that, we're going to make a second metadata object that is empty. Because if we were to say to reflect the user table into our existing metadata, it would be like, okay, I already have that table and I don't need to do anything. We want to see it do something, so we will make a blank metadata and make another table object. We will name it something different just to disambiguate it in memory from the other table. But it will have the same name because remember, there's 2 metadatas, but there's just one database engine. So we're going to actually say table user associated with metadata number 2, say, hey, table, you've got nothing inside of you, but please auto-load your stuff. And auto-load your stuff with this engine. It's history, I know, it's terrible. It shouldn't be there, I know. Because for a long, long, long time, the way SQLAlchemy worked, and everyone did it this way, in the old days, there was not a metadata. There was only the engine. The engine had the tables in it. And then one day, someone was like, I need to have multiple metadatas and engines, and it's too much linked. I need to actually use the same tables with a different database engine. And I was like, what? Who would need to do that? So I had to change everything, because seriously, this is why it took 0.1, 0.2, 0, because it took a long, long, long time for really obvious things like that. So when we broke up the engine and the metadata, I didn't want people to be too traumatized, so we had the metadata would have metadata with the engine inside of it. And we call that bound metadata, meaning that when you work with this metadata, it has an engine already implicitly present. And then that created tons of confusion for years because people had more complicated situations. So then entered the era of, please don't use bound metadata. And I tried to make it so that bound metadata is also an anti-pattern in most cases. So I had to add arguments everywhere. You see where this is going, right? Autoload true predates autoload with. But yes, you know what? I might as well, if autoload with is there, it probably should imply autoload equals true. I'll add that for version 1, for 1.0, because it's just, this is really how it happened. I just like people like, yeah, I mean, I've already seen that, and I see it, I'm like, yeah, that sucked. And then that you're saying it, fine, yeah, we should. It should, I mean, it shouldn't be, it should be accepted, but that should imply that, which is fine. No big deal. Yeah, so anyway, auto load. In SQLite, it's a pretty rudimentary, you can't see the results here. Pragma table info will give you like this result set of columns. And Pragma foreign key list gives you stuff about foreign keys and the indexes. If you were in some other database, you'd see much more elaborate queries. SQLite has pretty succinct information schema queries. So now this user reflected has all the columns in it. So if I say user reflected.c, you'll see the keys of those columns. The reflect thing that we just did nowadays uses another system that's more fine-grained, which I think is really cool, called the inspector. So you can load this. This is new as of 08, I think. It's from SQLAlchemy import inspect. And you can say the inspector is the inspect of engine. And that will give you an object that is specific to engines and knows how to inspect them. And inspector can do all this kinds of stuff at a very basic level without any metadata or table objects. Give you the names of the tables. And for whatever reason, it's in SQLite is doing more of the legit information schema stuff. These are the names of all the tables. It will give you the columns of a table that you give it as a nice, JSON-like structure, like Python list of dictionaries. You'll see that it just uses SQLAlchemy data types for the types because the type object in SQLAlchemy is pretty rich, so we still include that. But otherwise, it's just strings. There's no column objects here. And the foreign keys. So this is a great system because this works in every database. Because every database, MySQL, Oracle, Sybase, everybody has these totally screwy ways of getting at the table names and column names. There's a SQL standard called the information schema that only half of them implement, and they all implement it differently, and it's pointless. It's the biggest failure ever. But when you use the inspector, you really get a system that is completely consistent across every backend. Exercises. Everyone understand metadata? So we're going to reflect the network table. Column names and network table. Using oh, this is actually like a programming challenge here. Using inspector, print a list of all table names that include a column called story ID. For what first inspector? Does it get table or table names? Table names. Yeah. Okay. List of all table names. Okay. Single column story ID. Okay. It's for column. Not like you'd ever need to do that. I mean, find all the tables with story ID column. Publish and story. Cool? All right. Slideshow's over. All right. That means we're past this, okay? That means we're onto the core. I think now we're going to talk about some data types, some basic types. Integer makes int. String is for ASCII strings, generates a varchar, and there's also Unicode, which might be varchar or the so-called national varchar, depending on the database. I think Oracle and SQL Server maybe have nvarchar. Boolean. Now, not everyone has a Boolean. Booleans are really freaking hard to deal with because a lot of databases don't have a Boolean type. You know, on MySQL, they use tinyint a lot, and SQL Server, usually int. Booleans are tough to deal with. Date time, we'll do a date time or timestamp, depending on what the backend has. Float is the floating point value, and then numeric is a precision numeric. The difference between float and numeric in practice is that by default, a float will return a Python floating point number, and numeric will return a decimal. Because you guys know that floating points are just can't be trusted with your data. And you can flip them. You can have a float return decimals, although they will have rounding problems possibly, and your numeric can return floats, which will also have rounding problems because they're floats. Create and drop. Here's the varieties of create and drop that we show, just to see what it is. Create all. You can do check first, which means it'll either check or not check. Table.create, metadata.drop all, and table.drop. This is just familiarity with the variety of API. Everyone look. SQL expressions. All right. SQL expressions. SQL expression system builds upon table metadata in order to compose SQL statements in Python. We will build Python objects that represent individual SQL strings that we send to the database. These objects are composed of other objects that each represent some unit of SQL, like a comparison or select statement, conjunctions like and or. We can work with these objects in Python, and then when we execute them, also when we print them, turn them into strings, they become SQL strings. On to the slides. And that's actually not the slide name because I changed the names. The name is now 03 SQL underscore basic. So 03 underscore SQL underscore basic dot py. So we begin our chapter where we started earlier, with a table object with the metadata and with some columns, and then with our engine as we had before. So see, the onion is growing, right? We started with engines, and then we had metadata. Now we have them together, and then we're going to put SQL on top. It's awesome. We create the table that we just did, the user table. Now it's in the database. So as we saw before, we have this collection of column objects like usertable.c.username is this column called username. So here's the magic. The magic of SQLAlchemy is that the column is part of a class known as column element, which means that it's a subclass of column element. So if I were to show you this, did I get it? Yeah. It's a column. And if you go all the way up, you'll see, where is it? Here it is. Column element. What it means is it has a bunch of Python methods on it that are what we call in Python magic methods, like the underscore EQ method. Has anyone seen these methods before, the magic methods? Like EQ and NE and LT and GT. And what that does is it overloads operators. It means that when your object is on the left side, there's actually, well, yeah, there's some rules for left side, right side, but in the simple case, when you're on the left side and you compare it to something on the right side, this this comparison operator will invoke this special EQ method. And the construct in Python of the EQ method and the other comparison methods is that they need to return, well, true or false. But in fact, in Python, we have another magic method called, I think in Python 2 it's called non-zero, and in Python 3 it's called bool, which means that any object can also be a Boolean object. And in fact, you don't even have to return a Boolean, but we do now because we're better Python neighbors than we used to be. When we say this user table.c.username equals the name ed, we get we don't get true or false. We get this object called binary expression, and then we should see what that does. When we have a binary expression, which is part of the SQL expression system, we can turn it into a string, and it will become this kind of SQL string. The name ed has vanished and become a bound parameter name. It's still there, but you just don't see it. When you have column elements, those are your basic building blocks of SQL expressions. So you can do that. You can have the column, compare it in two names, and then use the Python bitwise OR operator to make an OR. And if you print that, which will turn into a string, you get, ta-da, you get, more SQL. This approach came from an earlier Python library called SQLAlchemy, which is written by Ian Bicking. There's another approach that some ORMs are starting to have used for a long time, but there's another one that's using it now, which is where they actually take Python functions and they use list comprehensions, and then they decompile the Python syntax tree and make SQL from that. And that approach, a lot of people think it's cool. Yeah, I'm going to show you that. So when we do the string here, this string, they're actually gone. But printing it is not what we do when we actually run it to the database. When we run to the database, something else is going to happen. Something more complicated, which I guess the slides will get there. So no, I don't want to jump ahead of the slides. Here, so this is another way to do and or. I prefer this. I think it's clearer. It's easier to read for me. Is just use the OR function, so you can put several items in an OR and several items in an AND, and you can compose an expression like that. It's pretty straightforward, right? Okay. Comparison operators, greater than, less than, or obviously all there. There's a little bit of magic with if you send none, it will figure out to convert it into is null. In SQL databases, you don't want to use an equal comparison to null, because in relational databases, null means we don't know what this is. So null is never equal to null, because unknown is not equal to unknown. You don't know what it is. There's some operator mechanics based on type. If you add an integer to an integer, you get a plus sign. If you add a string to a string, you get the concatenation operator. So SQLAlchemy can have operators that have type-specific behavior, and you can make your own operators too that do this. In works like that. You send a list to in, and you get an in. There's no shortcut with in as far as bound parameters. It has to render them all out, as many as are in the list. So here we get to the bound placeholders. So let's go back to username equals ed. So when we print it, we just see the column on one side, the equal sign, and then we see a bound parameter. But if we break down, if we unpack what's actually happening here, if we go more granularly, when we convert the expression to a string, what's actually happening is first it is going through this process called the compilation, which means that you take your expression, you call this method called compile on it. Compile, as you'll see in a moment, can actually takes a lot of arguments like which dialect would you like to compile to. If you don't give it a dialect, it uses a dialect called the default dialect, which is a dialect that works on no database. It's just default. When you have this compile object, it has contained within it the parameters. So the string is available, I think, compile.string or something like that. And then the params are there as well in a data structure that you can see here. So when you call string on it, first this happens, and then we call string on this thing, you get the string, and then the params are thrown away. But if you don't call string on it, you just have the compiled, you've got both things. And compiled actually has a lot of other stuff inside of it too that is used when we execute the statement. So when we take the statement and we execute it, the execute process does that compile that we just did. It unpacks all kinds of special things and plugs in things all over the place. And in this case, it also figures out on SQLite the default parameter style is called QMark. I probably didn't point that out before, that SQLite is actually supports multiple parameter styles. One of them is called named, which is :name. Another one's called QMark. Those are 2 of the 6 that are supported in DBAPI for absolutely no good reason at all. But SQLite's default is called QMark. So SQLAlchemy will also take that dictionary of names and convert it into a list in the correct order and do the QMark and do that because SQLite is telling it that it wants to use QMark. It doesn't matter to SQLAlchemy, it can do any parameter style without problem. Expressions produce different strings according to dialect objects. So here's that compile command, as we saw earlier, but we can send it some dialects, like a Postgres dialect. If we look at this expression with the Postgres dialect, we get the 2-pipe concatenation operator, and we get a param style called PyFormat. That's the 3rd of the 6 parameter styles. PyFormat. If we use MySQL with the default MySQL dialect, we get the MySQL concat function, SQL function instead, because MySQL doesn't have the pipe thing, it has concat. And Postgres doesn't have concat. Concat is a MySQL thing only. So this is the work that the dialect is doing, is figuring out who the heck knows how to concat a string. And then the MySQL dialect has yet another parameter format called format. It's the 4th Python DBAPI parameter style. And you can see they're all very logical. The question mark is logical because you see that in JDBC. This is Python's named interpolation. This is Python's. They all make sense, but not all 6 at once. They all make sense for their own reasons. And all the DBAPI authors are like, we need this style because our whole implementation builds on that. Mike Baer should have to deal with this. 6 parameter styles. Exercises. These are pretty simple. G full name equals ed. User table C full name. Edward. Oh, sorry. Ten more minutes to snacks. Okay, good. SQLAlchemy is making sense? I know it makes sense to you. All right. Inserts. what does that say? Insert. So we've had user table dot select. I showed you select very briefly, but let's just show inserts. If you have this table object, you can say dot insert. It makes this object called an insert object. Insert can then be further modified to call a method like dot values. What are the values we'd like to insert? And that will create a statement that will format correctly for this table, for those columns being in the values. We can make a connection to our engine because we want to use explicit connections, explicit execution. Execute it with our result. And you get the statement, SQLite, so we get QMark style, but we don't care. Doesn't matter. Added a Jones, auto commit. Did a commit for us because we didn't say transaction. Insert can also put multiple stuff. The Python DBAPI, when we work with that cursor that we saw in the very beginning, has cursor.execute. It has another method called cursor.executeMany, which means that you send it one statement and then a list of, or a sequence, any sequence of parameter sets, and then the DBAPI will run all of the insert statement over and over again with each parameter set using the optimization style of its choosing, which could mean that it uses prepared statements to do it quickly, or it just is written in C, so it thinks it's fast, or does whatever it has to do. The DBAPI currently does not have an explicit prepared statement API. It has execute many, which is kind of like a very simplistic facade over kind of a small part of what you can get from a prepared statement. They are discussing right now on the list how to add prepared statements to the spec, but it's not there for now. So when you want to run an insert statement with a lot of parameter sets, DBAPI has execute many. SQLAlchemy decided that if you just send a list to execute, it will figure that out for you, and it will call execute many behind the scenes, so you don't have to worry about execute versus execute many. So if I run that, from SQLAlchemy's perspective, it's just one statement with two sets of parameters. The DBAPI sees an execute many, and so runs both of these parameter sets with that function, that SQL insert. You get a result, which we'll see in a minute what that result is talking about with an insert statement. So when we have some rows to select, we can use the select function. So from SQLAlchemy import select. You can say user table dot select to select all the columns in user table, or you can just, I prefer to just import the select so that you can actually send it a list of what specific columns you want to select from. You have your select object that you can then say select dot where, and then put a SQL expression. So you can see the expressions we have are kind of building in to become more composed statements. So we could say result equals con execute statement for row and result, print all the rows, runs the select statement, and then you get your row back. Select all columns. You can pass the whole table to the list to select, and that will give you all the rows. Notice it doesn't say select star. Select star is great, but SQLAlchemy, when you use the core, doesn't need to do star because it always knows the column, so it lists them all out. You get all the columns back and all the rows. There's more of a where clause. We can take the or, and put that in, and we can do or and execute and return code, and this should be building on part we just did. No one's lost. Okay. If you say where multiple times, it will join them by and. So if you say select dot where this dot where that, it's the same as using a where with an and. So you can say where as many times as you want. This style of programming is called method chaining. And when I wrote the SQLAlchemy docs, somehow in my brain, I forgot the name method chaining and I started calling it generative. So, because I thought that generative, for some reason I had this memory that generative meant the same thing. And then maybe a few years later I Googled it, and no one uses generative to mean that. Only it was something I thought of, and I so the docs are kind of trying to piece that broken glass back together, and it's generative because it's a cool. I think it's an easier term, generative, but it's not the right word. So we kind of have a glossary now with method chaining means generative. Sorry, you know. So method chaining meaning that you have an object, and then you keep calling new methods, and you keep getting an object back each time you call a method. Now, with method chaining, there's different ways to do it. If you use like Hibernate in Java, the Java's ORM Hibernate, they have some method chained APIs, and you get back the same object each time with more stuff added to it. That's probably not what most people expect. Method chaining in most cases that I've ever seen, you get a new object back. So when you say select, you have this one object, like ID number 1. You say dot where, you get a new select. So you have the old select and the new one are both present if you keep the old one around. And then you say where again, you get another new one. So it basically clones it each time and adds more state to it. That way you can take the same object and then kind of branch it off and call different things and make different things happen with it without any concern about the original object being changed. The original object is kind of semi-immutable. It's not immutable, you can change it, but when you do this style, you kind of treat it as immutable. Exercises. So now we're going to use table insert. Let me assign it first to make this easy. Gilbert. I'll show you something that I might show later. When we insert a row, there's also a little, the result for an insert has other stuff like the inserted primary key. So the primary key of the new row is 4. There's a lot of other little stuff that it has that we use for stuff. Oh, I didn't finish the exercise, I'm sorry. How can we do this? 26. So there's like 3 slides left. So let's do the three slides and then we'll do our break. How's that? This is an update statement to round out insert and select. Update looks a lot like insert. An update statement in SQL has a set clause, like set this and that. We still call it values because it's kind of the same class hierarchy as insert. You just say values. It's the same as the set clause. Update this table. Set full name equals Jack Brown, where username equals Jack. Does that. That's an update statement. It works a lot like an insert. Update can also use expressions. So we can give it the key as the full name column, but we want the value to be a SQL expression that is derived from the user table. So that's a string concatenation. So you see we get an update like this. With the question mark in the middle is actually that space, because anything literal by default becomes a bound parameter. Does that make sense? Sorta? Okay. That's just showing off the rows. That's a delete statement. Looks a lot like an update. Delete from user. I'll just whip through these. Execute this update. Keep this result that returned. Okay, UPD. So when you run this update statement, there's a row count. Show you how many rows are matched. Which means that when this update statement ran, the where clause located rows in the table, it hit one row, matched that row, and updated it. Row count is 1. Delete the row. The row is gone. We can take a break. And then that'll be the second half. So these are the same link, and they want you to do the survey. You got me, audio? Okay. Okay. Just about everybody back? Just about. Are we ready to video person? Oh, so I started. Okay. Welcome to the second half. Everyone got the link? Yeah, they're the same, sorry. Oops. All right. So you got one of the, right. So I'm going to do the object relational mapping. The final layer of the onion. The outer limits of the universe. Oh, not everyone's here yet. Okay, well. Object relational mapping. Object relational mapping, or ORM for short, is the process of associating object-oriented classes with database tables. We refer to the set of object-oriented classes as a domain model. So you've got your whole set of classes, and that's your whole app, and the whole set of classes that all talk about some concept is called the domain model. So at the most simplistic level possible, the most one-liner ORM in the world should do this. It should be able to take the domain object from your application and persist some kind of a row into a table row in your database. And it should have some kind of system to retrieve the row in the database back into a domain object. So this is the most basic function of the object relational mapper. And this is totally above and beyond everything that we did in Core. Even though we got database rows back in the Core, those rows were just Python. They're just Python. We only have one slide. You only missed one slide. Those rows were just Python tuples. They weren't custom objects, classes that we've defined for our model. So object relational mapping is specifically, in my view, when you've actually created a custom model that's going to be filled in with database data. So some ORMs can also represent arbitrary rows as domain objects. That is, not just a row that came from a table, but you could load a row from a select statement that actually is joining two tables, or a row from a view. That's a row also. In relational databases, a row is a row is a row. The row that you get from tables or joins, they all look the same. They're all just tuples of data. So you should be able to load domain objects that also are from arbitrary rows. And then the big thing that ORMs, well, not the big thing, but a very big thing that most ORMs do, and this is where they get complicated, is how to represent compositions. So the composition in your object model, well, there's many kinds of compositions, but the kinds that we usually refer to in object relational mapping are the one-to-many and the many-to-one. So if you have an object, in here we call it parent, has a collection that's a one-to-many and contains any number of child objects. Anytime you have a one-to-many, there's implied many-to-one, meaning those child objects have a parent. How do you represent that very common structure in the relational database? Child will have a different table than the parent. Actually, not. It could be the same table. You usually will have foreign key references in your database that match the relationship that you're making. And the foreign keys point in the many-to-one direction, meaning the dependent table will have a foreign key referring to the table that it's dependent on, meaning we have this column called parent ID. So for every row that we have ID that has to be present in our table that we're dependent on. So an ORM will mediate this system. It'll figure out all the nuts and bolts that when we're in, this is where we live. We live here, and then the ORM is dealing with sending messages back and forth to there to make sure that this looks like that. Other things ORMs do provide a means of querying the database in terms of the domain model structure. That kind of means like the selects we're doing, we can do them kind of using our domain model as the template. You can represent class inheritance hierarchies, like classes that subclass another class, and you can have different tables that represent the class hierarchy. You can handle sharding. You might have your model living vertically in different tables across different schemas. You might have what's called horizontal sharding, meaning that you have like millions of customers, and like customers A through F are in one database and G through whatever in the next database. There's patterns for concurrency. How does if you deal with your objects and you want to persist your objects, how does that interact with the transaction model of a database? What happens if you have data in your application that has gone stale? Some other transaction has updated the row, and you have this older row, and then you want to persist it, and it's the wrong version. There's ways to catch that. Provide patterns for data validation. Coercion, you have various kinds of business rules that as data comes in, you need to check it against things and modify things and change the type of data going to in and out of the database. Flavors of ORM. So that's going to sound great in the tape. It's my cold. Two general styles of ORM are active record and data mapper. You've heard of active record. It's the name of the Ruby ORM. It's called active record. In active record and domain data mapper kind of often refer to how ORMs are configured. I think it's a little more of how you deal with the object at the day-to-day persistence level. An active record ORM usually has this kind of pattern where you create a user object or your domain object, and it's got a .save. And when you say .save, it just insert. And if you change it and you say .save, it does an update. So it means that the object itself, which is your part of your domain model, has these little persistence methods tacked onto it. And every active record thing I've seen seems to do that. Whereas I think data mapper is more about your data models here, and then there's something else over here that represents how they're persisted. SQLAlchemy is a data mapper. Hibernate is a data mapper. There's this session or something that is over here, and then your user is over there, and then they kind of mix it up over here. You add the user to the session, and then there's some kind of commit, like push everything out. I mean, this is really what's called the unit of work pattern, but I think a data mapper ORM typically has this kind of thing going on where the objects that you're working with are not also the persistence API. The persistence API is separate somewhere else. This could be dbSession.save, and it emits the insert right there. It would still be more of a data mapper. And then the other idea with data mapper and active record, which I kind of think of it a little differently, is how they're configured. How do you define your domain model? How do you define the tables that they're mapped to? How do you define the interaction of your domain model's fields and the tables fields? And this is, most ORMs, including SQLAlchemy these days, have something that looks, this is not SQLAlchemy, this is just a faux ORM. But there's something like this where you make your domain model and then it kind of has stuff inside of it that tells it how to persist it in the database. It's kind of all in one, right? It's in the one, if you have a file called user.py, it has the class user, everything about the user plus how it's persisted is in one declaration, or maybe a set of, maybe a sub-declaration, something like that. And we kind of call this the declarative style. And the other style is, this is what people sometimes call data mapper. I don't really know. I don't care. This is the other style, which is the domain model and the mapping is separate. So, and this is actually SQLAlchemy code, because SQLAlchemy does it both ways. One part of your app will have these totally clean domain model classes set up with nothing to do about databases or persistence. They have no awareness whatsoever. And then somewhere else, you can map your classes to tables. And this is fine. And this is a very pure form of configuration. If you use Hibernate in its classic style, this will be a big XML file. You'll have your Java user.java, and then you'll have the user.xml stuff going on with a huge XML file with this kind of detail. And it's fine, but it's really tedious and verbose, and it's redundant because you've got name is like, it's more pure. Some people like this way, and I wrote SQLAlchemy in the beginning to work this way because I thought it was better. And then the first day I finally got a job that I actually was going to write my work project in SQLAlchemy. That's the first. I was like, oh crap, this sucks. I can't use that. It was terrible. It's like, I'm not going to type all these tables down. It's so repetitive. So it's this trade-off. Do you want to be pure and have and act as though your model is totally unaware of any way of persistence? Everything I do tends to fall on the side of practicality. It's not that big a deal to me that the persistence model is a little bit wrapped up. A little bit, not too much. There's always a balance. So SQLAlchemy is essentially the data mapper style. Modern versions use declarative configuration, and then the domain and schema separate is present underneath this layer, and we call that classical mapping. The ORM builds upon the core, and a lot of the stuff that we just saw with the SQL expressions with the equal sign, the and the or, all that stuff kind of happens at the ORM as well. And I think I said this in the beginning, the ORM you're dealing really with your domain model front and center and how it persists to the database rather than dealing with the tables and columns directly. Even though they're similar, they're not quite the same. Key patterns used by the ORM, the unit of work. This means that objects are maintained by a system that tracks changes over the course of a transaction. It flushes pending changes periodically, as opposed to just saving when you say .save. It kind of just accumulates changes, and then when it needs to, again, the lazy pattern, right? Only when you need to, that's when it flushes out a whole bunch of inserts and updates and deletes. The identity map pattern means that objects are tracked by their primary key within the unit of work and are kept unique on that primary key identity. It means if you have a certain object from a table with a certain primary key, there'll only be one of them. If you do another query and get the same row, you'll get the same object back, so that you can have those two objects are actually the same. You won't have the issue of different state in two different objects that indicate the same row within the same transaction, which can lead to a lot of confusion and problems that are totally unnecessary. Lazy loading. You might access an attribute on your object that is not loaded, and at that point it will actually emit SQL to load the value of that attribute. Lazy loading is kind of the #1 reason why ORMs like SQLAlchemy are not compatible with asynchronous programming. Right? That's why you can't use SQLAlchemy with Twisted or Tornado. The only async approach would be the G-event approach, because lazy loading really means that you're just kind of moving along through your objects, and you say, user.name equals x, user.addresses, load the address. Oh, that would be a deferred right there. Ruins it. That's the biggest hurdle and that's why you'll see me kind of, not often, but I'm not really into the explicit async, like the Node.js thing. It's like, I'm kind of on the callback spaghetti side of things, but that's an ongoing debate that we can all agree to disagree on. Eager loading is the opposite of lazy loading. Multiple tables are queried at once in order to load related objects and collections. Meaning you load the primary collection of stuff, it'll also load other collections at the same time, either within the same query or within another query immediately. And then method chaining, which, aka generative. Queries are composed using a string of method calls, which each return a new object. And then we go to the walkthrough. And that's also the wrong name. So there's 2 ORM presentations here. We should be able to get through both ORM Basic and ORM Advanced. So now things are going to look a little different because we're going to kind of blow past that whole thing with the table that we had before. It's going to be there, but not in the same way. What we want to do with an ORM is we want to build a domain model. We want to build classes that represent the concepts in our application. And when we want to build these classes, the classes are going to have information in them that talks about how they're related to each other and how they're linked to tables. And for that reason, they want to be able to find each other. So by convention, and this doesn't have to be how you do it, but this is one way this is the most common way, is that you make this base object called the declarative base. And all the classes that we make will descend from the base. It uses a Python meta class to make things happen when you first declare your class so that it keeps track of the name of the table that it talks to and the columns and holds everything in a registry so that classes can refer to other classes by name. All optional stuff, but all very, very useful and handy, and you'll probably want to use it. So the first class we make is we're going back to the same structure. You know, I'm trying to maintain the same structure so you know the data we're working with is kind of this user addressed thing, which is ubiquitous throughout our tutorials. Again, we're already talking to the core here. Is we're loading back again core column integer string, the same objects that we had in core, except now we're kind of sticking them into our class as class level attributes. So this looks a little bit like the table we made, but what's different is that when we made the table, that was actually calling the Python constructor of the table class. This is actually making a new class called user, and this is class level. So we haven't actually called the constructor. So when we're here, we actually can say, you know, x equals something. So the names are no longer, they could be, but by default, you don't have to put the name anymore. The name can be out over here, because basically the user class will have this user.id, user.name, just by doing this. Does that make sense? People know Python class mechanics enough to know about class level attributes. All right. You could put the name, and if you wanted the name attribute to have a column of a different name, like full name, you could put a string in here. If you like, you could put the string full name as the name. It's kind of open-ended. This has a reaper method because it doesn't have to, but just for this thing, it's going to be printing it out just so you can see what the class looks like. The reaper is optional. The constructor is optional. Something that will tell declarative what table we're talking about is helpful, is usually required, and at the least it would be just the name of the table, the user table. We didn't actually make a table object yet. Actually, by creating this class, the table object has actually been created for us when the meta class ran. So there's actually a table object stuck inside of here somewhere, inside the registry of stuff. The user class now has a table associated with it. So if you want to see the table, we say user dot and then double under table. So that just was magically created for us. And it's the same old table that we had from the core stuff. Not too mysterious? Okay. Another object that we'll just kind of note that it's there, we're not going to do too much with it directly, is the mapper. The mapper is the SQLAlchemy object that represents the linkage of a class to a table. It has all kinds of information stored within it about how this linkage is configured. It has a lot of informational methods. Normally, we don't need to deal with the mapper directly very much at all. Yes? So right, so is, okay. So we want all the classes in our domain, they're all going to extend from a common base. We make the base on the fly because there is stuff in here that is like a collection of data about our classes. So the reason is the question, why do we call them the function instead of having just a fixed class? It's because this base class actually has information about that collection of classes. And if we had what if we had a library that also used SQLAlchemy and had its own domain model with its own classes? They would have their own base. So you'd have two bases at once, because their library might also have a class called user in it. So what happens is when we make the base here, there's actually a base. The metadata collection is on that, and then the metadata has the tables in it that we created. Yeah. And then it also has this thing, which is it's a weak. These are all the keys of the. That's our class. So it has a lot of data on it. So basically, as we build our model, our domain model, the base is accumulating information about it that will be used to reconcile things later. So up here, we make a user like we always did, and this is basically this just an add user object. And what can we look at add user? Let's see. Oh, there's a default constructor on it. When we declare the user class, there's no init method here. Declarative will give you a convenience init that will take as keyword arguments all of these names. So it takes name and full name and ID if we wanted to, but we're not going to do the ID here. We'll show you how that gets in there. So if the ID field is the primary key, it starts as none if we didn't set explicitly. So we print out the values of add user, the name and the full name, add Jones, and then the ID, even though we didn't assign to it, kind of implicitly becomes none. This object does not represent a database row yet. It's just an object in our Python application. Once again, we go back to creating the engine and the metadata, create all the tables, the user table, the crap. And all right, so now, whereas before the engine was really critical with the core stuff we did, with the ORM, we don't really deal with the engine directly very much at all. We use it for create all. And then the next thing we do is we take the engine and we just shove it off into what's called a session. And then we're kind of done with the engine. We're not going to be saying engine execute. We're not going to say engine.connect. We're not going to say any of that stuff. We now will work with a whole new interface called the session, which is an ORM object. If you're not using the ORM, you don't need to use the session. A lot of people get confused by that. So the session is now, whereas the engine is a facade over the Python database API, the session is a facade over the engine. So the session is where we can put these ORM objects. It has this method called add. We could say, hey, session, add this add user object to your list of objects. OK. I would note that nothing has happened with the database yet except that create. The session hasn't made a connection to the database. It hasn't looked at the tables. It hasn't inserted any rows. It's done nothing so far. But the session now has this user object as what's called a pending object. It means it's part of the session, but is not yet inserted into the database. It's in the state called pending, meaning that it will be inserted when we need it to be present. The first time we need it to be present is when we query the database. So we're going to say to the session, hey, session, we want to query for users. And the session is like, oh, OK, well, let me first flush my pending changes, of which this one object to be inserted is the pending change. So it will flush the pending changes first. Then it will emit a select statement for this query, which looks kind of like the select. It's got filter. It's another inconsistency that is unfortunate instead of where it's filter. But otherwise, and it's going to get the first row back. So this is a different API. So what we'll see is first the insert, and then we'll see the select. The session is like, OK, let me auto-flush, but also let me begin a new transaction. The session always works within a transaction. I mean, there's ways to change that, but by default, as soon as the session begins its work, it's like, OK, let's start a new transaction. And then let's auto-flush that user object. And then let's select the row. And we get the object that we just inserted back. So what's the first brain flip here is that nothing, when we said add, nothing happened. Everything happened later, only when we needed the database to have some meaning to it. So that same object, when we used to say this was none, it is now changed to the number 1. So the ORM assigned the primary key to the object, and then now it's the number 1. And then the identity map thing happening. You know, in Python, you can say x equals y, and if the two objects are the same object, you'll get a true. If the objects are different objects, you might still get a true because they might have an EQ method that tells them true. But the is operator cannot be overloaded in Python. It means these are the same object in memory unconditionally. So that's why, bless you, that's why is awesome, and it could tell us unconditionally that the object that we first inserted and the one that we got back from our query are the same object. And your garden variety active record ORM will not do that. Your garden variety ORM, active record ORM, will kind of have this user object that gets saved and this user object that's the result of a query be different. Because it just kind of goes through the database, gets rows, oh, every row make a new object, every row make a new object. What a unit of work / identity map ORM like SQLAlchemy will do is as it goes through the rows here, it sees a row of primary key number 1, it looks locally, hey, do I already have primary key number 1 locally present in my identity map? And the answer is yes, it's up here. And instead of creating a new object and giving you that one, it just gets the one that's already there and gives it back to you. And that's another major conceptual thing at play with the SQLAlchemy ORM and a lot of other ORMs. That's what we mean by the identity map. Yes?
What would happen if we try to call add twice with two objects that have the same primary key?
If they're both pending, meaning they haven't been inserted yet, it'll succeed at that point, and then it'll throw an integrity error in the flush. If they are persistent objects, which means that they were loaded from some other session, and we know that they have a primary key identity in the database, you will get an error when you add them. It'll say that this identity is already present in the identity map. So basically, the identity map only has rows in it that were inserted. So when we first when we first add this object here, the session has this map, identity map, of primary key identities to objects. Whether or not this object has ID on it, if we said add equals new user, primary key is 1 or 2 or whatever, that means nothing to the session as far as the actual database, because it's not there yet. It doesn't know that. So the identity map would be empty. Only when the object moves into what's called the persistent state does it participate in the identity map. So there's basically like a layer of indirection between what we tell the session is a primary key versus what the database reports as primary keys. And a lot of crazy things can happen. We could actually have a database object with a primary key that's persistent, and then we can add another object with the same primary key, which you think would raise an error, but we could then say, oh, delete the other one. It's a delete and insert, so it actually is valid. So you actually can have a pending and a persistent with the same primary key. It's a flush time that we figure out what's going to actually break in those cases, yeah. Yeah, that happens a lot. That's it's really funny you should ask that. The thing about retrying with flush is that flush needs to roll back the transaction. So at the very least, you got to use, well, with an exception I could tell you about in a second. Normally, for small scale flushes that you think might fail, you use a save point. So the save point can give, because the thing about flush is that there's a whole FAQ entry about this, is that the flush can't fail and then keep the transaction going because it doesn't know, it can't reconcile the state of what's happened because it doesn't have that much granularity to it. And in many cases, if you get an integrity error in Postgres, you have to roll back anyway. So it rolls back. So a save point will allow you to roll back to a more local point. As far as replaying the transaction, that's a bigger deal. And I actually just wrote that for a client, and they are allowing me to add that as an extension. And I'll have it. The plugin will be there, but it's. I think replaying a transaction is a very intricate process. It has to actually, as the transaction proceeds, it has to log every statement, and it has to do a lot of work. It's complicated. And I gave it to this company, and they're going to play with it and see if it works. And then we'll have that. But yeah, I try to stay away from that whole use case like the plague, because I think it's too complicated. But we'll see if it works, because someone paid me to do it. Anyway, identity map. So we kind of get what the identity map is doing. I have no idea what's next. Oh, add more objects, okay. So if we want to add a bunch of objects, we can call add all. Okay, so add all. Nothing has happened yet. They're pending. Let's make a change to the existing persistent object, add user. Another pending change. Nothing has happened on the database side. Let's look at the session before we flush to see what's going on. The session has a list called dirty. Objects that are dirty means they have they've tracked some kind of state change, and they will most likely result in an update statement. If there is no net change in the values, then there will not be an update statement. So if I said eduser.name is ed, the same name, that would put that object into the dirty list. But there wouldn't be an update, because when SQLAlchemy actually flushes, it actually looks at each column to see which ones have changed. So there's kind of two levels. But in a simple sense, the objects that are pending to be updated are going to be in the dirty list. And then the new list is the stuff that's pending. So these are the 3 objects that we added that are not inserted yet. These do not yet represent real database rows, but they will. And then, recalling that the session is totally working inside of an open database transaction that hasn't been committed yet. When you commit, that's the other time that a flush occurs. So we saw that a flush occurs right before a query. A flush also will occur right before we commit, within the scope of the commit. So we say commit, it'll first flush, then commit the transaction. So we can see the flush of all those changes. First, it will update the thing that we did, change the full name, and then we'll insert the other 3 rows and commit the transaction. That's the first part of unit of work. So it's a little more indirect, it's a little more weird, right? But it works out really well. It works great. It works really well.
So, does it sort of always like group the updates first before the inserts or something like that?
Well, there's some various rules for what it's doing. The inserts it's going to try to do in the order in which we added things to the session. The update before the insert, in this case, I don't know that there's a deterministic nature to that. Usually, what it will do, it will always do a certain table. Like it'll do all the user rows, and it'll do all the address rows, and it'll do all the network. So it'll group things by table first. If there are reasons that it has to break things up into per row, like you have rows that are dependent on each other, then it will work everything into what's called a topological sort and like a dependency tree. So it basically has 2 levels of dependency tree. One dependency tree is based on tables that are dependent on each other by foreign key. And if that's not good enough, if there are cycles in that tree, it will break it into per row dependencies. And then you don't know what you're going to get based on, I mean, again, we'll try to group things. If you have like a lot of user rows and there's like maybe 1 or 2 rows that have a self-referential link between them, it'll try to break it up so that just those 2 rows are in their own separate thing. Does that make sense? So yeah, so there is one behavior that is generally the case, and there's a new change that I might put in version 1 to help this, is that it will do all the inserts and updates before all the deletes. And that's just kind of a product of how it's worked out, is that to do any deletes before updates, there's a lot of cases where that gets all messed up and broken. But there are a few cases where you'd need the deletes before the updates, which is that case where you want to insert a row to replace the primary key of the other row. So in all cases right now, we'll do deletes after updates and inserts. unless you call flush twice with specific things. That's how you can work around that. There is an option I'll be adding soon that will allow you in some cases to be able to put a delete before an insert in case you're switching a row, like with a unique constraint. So yeah, there's kind of rules to it, and they're defined. Although I can't, I don't have the moment. I'd have to, write it out somewhere. So yeah. So after we've committed the session just now, the transaction is gone. So again, this is all default stuff that you can change, and this is not how it used to be in the old days. When you commit the transaction, the session is now in the state where it says, you know what, the transaction's over. I know nothing about this database now, because with our transaction over, anything could be happening. Any number of other things could happen to change the data that we have. Only when we start a new transaction will we really be able to tell what the current state of the data is. So what it does is between transactions, it expires all the data. So we still have all the objects that we made. They're still Python objects, but their guts are emptied out. Basically, the context of their attributes are emptied, and they've all been affixed with a pattern. They've all been basically what's called expired or invalidated. When you access attributes on these now persistent objects, the session will awake again, begin a new transaction, and then resuscitate the object that you're asking for, and it will reload everything again. So when we after the commit, just by asking this one object for its attribute that was just plainly there before, it has to go start all over again. Begin a new transaction, select the row, and get it back. And so now we get the data is back now. So now we're back into a new transaction. It took a very long time for SQLAlchemy to kind of come around to working this way. It used to just be it used to never invalidate data, because when I first wrote it, it was kind of like I was writing it to try to minimize the number of database talking as possible. And then eventually, and we had a lot of people constantly complaining about, well, I needed to expire everything. I need my data stale now. I needed to do this and that. And I'm like, well, what can we do? We can't have it do a query. We can't have it, because of the unit of work pattern, we can't have it like overwrite everything every time. We can't have any pattern that does that. So I eventually learned from another ORM called the Storm ORM, which is from Canonical. They actually copy a behavior from Hibernate, which is that they consider the end of the transaction to be the best place by default to expire all the data. It's true that if you have your transaction running as it goes, within the transaction, you might want to, some data might have changed elsewhere, and you might want to see that new data. And again, if you're running with a very low transaction isolation level, you might be able to see that other data. But if you have a higher level of isolation, you probably won't be able to see the changes in a concurrent transaction anyway. So for that reason, the default setting of we expire at the end of a transaction works out really well. Now, who did I lose with that? Because I just got a little more technical there. Yeah. It took me a long time to get my head around it, so I don't know. Basically, the only thing you have to remember is that when the session commits, when the transaction ends, it expires everything. That's really the only thing. It's just like the rationale for it was more complicated, and it took me a long time to get my head around why you would want to expire things when the transaction ends. And you wouldn't want to expire things too often at other times. What it means is that as you work with your object in the transaction, the attributes are just there. They're just plainly there. Whatever you set is just there. But then when you commit a rollback, it has to require the database. If you don't want it to do that, you can turn it off. If you're like writing a web app that you don't want to require the database, you can turn off expire on commit, and it won't expire things. But the default is to work like this. And maybe the next few slides will make it a little clearer. We'll see. It's hard to tell. So with this new transaction, let's just go with it. Let's make a change to the ed user name, Eduardo, and make another user that we want to delete. And then we add this other user as pending. So these are changes that are only in Python. They're just pending. They're not in the database. And then if we want to query for those, the query will say, OK, let me auto flush first, and then we insert those changes, and then let me do the query. So I do the update. I change the name. I insert another row. I then do the select, and I get those objects back with the the new data, but it's not committed. This is a pending transaction. When I roll back, the rollback also will end the transaction. This actually will emit to SQLite, hey SQLite, roll back the transaction. So the rows that we just inserted and the row that we just updated, those changes have been rolled back. So as the transaction ends, SQLAlchemy again expires all the data. So even though we just modified a user object, we discarded those changes because we now again don't know what's in the database because the transaction's been rolled back. So if we look at user again, same pattern. It's gonna say, oh, I need to make a new transaction and reconnect to the database. So that way, it kind of works out that this is a good place to actually recreate the database because we did the rollback. So basically, SQLAlchemy is not trying to copy in memory what the rollback did. It just lets the rollback happen. It expires everything it has, and it assumes it has to go hit the database again to see the previous state. It doesn't try to recreate that state of memory to mirror the rollback, if that makes sense. That is exactly what it is. That is exactly how I describe it in another one of my talks, is that the object is really a proxy to a row in the database. And we assume that any row in the database, we only know about when there was a transaction in play. If there's no transaction, then we assume we don't know what the state of that row is. And that's really the model that it does. Yeah. I wanted to do that. It's really the undo stack, like to roll back the changes to memory. Yeah, no. I wanted to do it that way, and it was getting really. When I tried to do it, it was really. I mean, it works for simple attributes. It's easy, right? But we have collections of stuff to collections to, and it was getting crazy. What it was happening was it meant that I would have to track many more things to know how to roll it back. And one of the big problems with SQLAlchemy and Python is the performance of things. Is the fact that we're tracking changes as we set things reduces performance kind of significantly if you're actually setting up a big structure of objects. If you look at the Python profiling, there's a lot of work with change. There's a lot of that happening. So I couldn't add to that and make that more complicated than it already is. So yeah, right. It theoretically maybe, but no, it doesn't do that. There's not really need a ton. It would be nice to have that, but we don't really need it. You don't need it. It's always another way to do it. The ORM, as opposed to the core, has to take a lot of positions on things. The core, is just like, here's your SQL statement. I will not judge. I will do any SQL thing you want, whatever ridiculous MySQL structure, MySQL thing that I hate. We will support it if we can. But the ORM is more opinionated. It has a lot of, it's more doctrinaire about how things should be done. So the ORM is where we have all the tickets where people think it should do that, think it should do that, and I have to really think philosophically, because really, if I just implemented everything everyone asked for, it would really be a disaster. Because we already have, some of the biggest challenges with SQLAlchemy was removing features that were not well thought out. It's really, you just can't add little features because if they confuse people or they mislead people, or it's really a challenge for a long-term project to keep features coming in that add to what it presents without confusing it, complicating it, producing inconsistent behaviors. So with the transaction rolled back, add username is back to normal, does the select again. We're back in a new transaction. And then also it evicted the previous row that was pending that we didn't want to insert. That row is no longer in the database because we rolled it back, so it pushes that user out of the session. We can always put it back in if we want and start again. And the data is gone from the database too, so we have back to the start. So the state of everything is rolled back to what it looked like both in the database side and on the Python side. All right. Basic mapping, so 1133, and we have 18 more slides. Well, let me do this one quick. If I can do this one, class net. Is it 1220? That changes things, okay. 1220. Right, you're right, 1220. Let's type more slowly. No, all right, so. No, what happens is when I get to the next one, the last 10 slides, I'm gonna be like, and you're gonna be like, and that's how it always is. The less important stuff is, I mean, the stuff at the end is important too, but this is the more foundational stuff. So, yeah, at the end, I get into ego loading, and I'm just gonna be whipping through it, and it's just an intro. It's an introduction. My indent's wrong. Oh, pfft. They call it session? Is that what it was? Yeah. Oh, just a list. Psh, who wrote this crap? Okay. I want to commit them. Okay. Nullable is true by default. Because in DDL, a table column is null. Like it implies null, whereas not null is the non-default. So we do the same thing. All right. So we've seen a little bit of querying so far. You've seen the query object a little bit, which looks kind of like the select from the core. It's the way that we select rows. It happens from this session. At the level of the mapped user class, I talked before about how we can query the database in terms of the object model. At the very simple level, it means that the attributes that we stuck onto the class act like columns. Even though it looked like name actually was a column, it actually is not a column now. It's another username is actually another wacky thing called an instrumented attribute, which is totally not friendly to see. If you wanted to, you don't need to do this, but if you wanted to actually see the column, it's in here. And I know that because I have to fix this all the time. So that's where the column is. But basically, you don't have to worry about it. This is just inner gut stuff. The point is that this bizarro and instrumented attribute thing acts a lot like the column that we saw in the core, where you can say double equals, and it makes a SQL expression. So when I say username equals Z, you get that binary expression thing from core again. So this is how, the ORM is building on core. The core is totally all over the place within the ORM. We also could just, use the user table like we did before, because the table, remember that's our table. That's still just a table. You can still say this. If you want, you get the same. You get not quite the same. It's actually not the same, but it's for all practical purposes the same thing. So the column namespace is available from the table. It's available from this other interface that's on the class itself. So we don't really have to worry about the table object explicitly most of the time. We really don't need to worry about it. We can deal with just our classes and the attributes that are mapped to us. So this is how SQLAlchemy kind of hedges between being a purist school class/map database are separate, while at the same time being kind of convenient, like your active record, everything is just one big class with the columns on it. There's kind of this indirection going on where the table is separate from the class, and there's the column is over here, and then this other thing over here. But it kind of makes it work out so that in practice, it's not that big a deal. If you work with a more simplistic ORM, and you say, class user and name equals column, that's just there's not as much mechanics going. There's no table object. There's just the column. It's not as complicated. SQLAlchemy, of course, wants to be very complicated, so it has to have the separate table and be kind of purist about it. So a query, looks a lot like a select. It's a little more slick. You basically start with your session, which is kind of our ongoing transaction. Everything is in terms of the session that we're working with. And then we say, hey, session query for user entities, and give me those entities where username is Ed, and order by the user ID column. Now this, if you were in the core, you could say select user table where username. It would look very similar structurally. Instead of saying like connection execute statement, the query has executor methods right on it, like all, which will give you all the rows that the query represents in terms of the session connected to that transaction that we're doing. So you get, and instead of getting the result tuple, you get actually a user object back in a list. And it can give you individual columns, and you get back plain Python tuples. They are actually named tuples, so you can actually refer to name or full name for these as well if you wanted to. Python named tuple is a tuple that has dot names on it so that you can, yeah. It's in this Python standard library. The ones we use here are not the same for performance reasons. So I could say row name and row is a tuple. So that's what a named tuple is. This is actually called a keyed tuple, which is a local thing. The reason is because if you look at Python standard library, if you look at named tuple, it has this very complicated system for making a new named tuple. And in our case, that would be meaning calling the named tuple meta constructor for every result set, which would be too time consuming. We have a different way of getting to the same result, basically. And you can mix entities together. So if I can say query for user objects and the name separately. What I use this for, let me get some water here. So in this example, I've queried for a column and an entity at the same time. And so you get them back as, again, the name tuple where the object is here and then the name is there. Now what this is handy for, I'll do this a lot. I'll say, which is pretty slick. I put the name first, and I use the Python dict constructor, and I get a dictionary of name to object. I do that all the time. It's Python. It's great. You can do this. This is every ORM does this trick. You can put array indexes on the query, and it will convert them into limit offset. So if you put give me just the second, well, the third element, number 2, it'll do the limit. Give me just one row and offset the result by 2. It'll do that. It'll do the at Django does, everyone does this. The array slice thing, same thing. Do that. If you give it a negative array slice, it's not going to work. There's no negative array slice converts a limit. Filter by is kind of the basic way to do a where clause. Filter by takes keyword arguments. It's like less typing. You notice we're not saying user.fullname. We're just saying full name as a keyword. Filter by is for that quicker form, whereas filter is more of the full-blown expression in the method. So it kind of depends on what you are going for. Filter by is less typing, pretty much. There's no other reason to use filter by. Filter, you can put any kind of SQL expression in the box there in the parentheses. like that. You could say filter users where username is user ID is less than 5, or full name is @Jones, and it'll do the or. So filter is kind of the workhorse of any SQL expression you can put in there. And just like select.where.where, you can say query.filter.filter, and it'll method chain them and give you the filters separated by and. No big deal. And okay, then the query, the variety of returning results. So we have this query that represents all the rows where the full name is @Jones, and we can say query all to return a list of all the rows. We can say query first just to give us the first row, and if there is no first row, it'll return none. And you'll notice what first will do is it'll also do the limit, because it first means we just want the first row, so it'll make sure we only limit to one row. The reason that is helpful is that most Python database APIs will load all rows into memory unconditionally. So if you queried a huge table and you just said, give me the first row, the database API would by default load everything into memory first before SQLAlchemy ever gets to it. So we add the limit there just to get the first row. Then there's a variant on first, which is called 1, which will not do the limit. What 1 is doing, that is when you want to load a row and also assert that there's one and exactly one row. And this is good when you are doing a query that should be by primary key or by some unique key. If you write like a REST API and someone is doing a get of a resource, you might want to use 1. And if 1 raises an exception, you can throw a 404. So when query 1 runs, it just hits the query as it is and gives you the one row without a list, just gives you that row by itself. If you query for a row that doesn't exist and you say 1, you get the error that no result is found. So you write your web app and you catch no result found, and if no result found, then you throw 404. Now, if you query for 1 and there's more than one row, you get multiple results found. And that means that your query is broken. So that's why 1 is cool, is that it's for all those cases when you know you need to get exactly one row, and if you don't, then that's unexpected. You can break it up into the two exceptions. Like there's no result found, sorry, 404. Multiple results found, your program is not working, it shouldn't have queried that way. All right, ORM querying. Now I'm bored with these. Query object represents a list of full name values for all the okay. Queue goals session. Feel free to sing along at home. Full name, order by user, full name. Build a second query from the first. It also selects only user names with the row Mary or Ed. Q2 equals Q. Return only the second row of the query for number 3. Okay, print Q2 first. 1. There's your row. Pretty good? All right. That's it. Really? Wow, going fast. Sorry. We'll have time to chat at the end. Weird. I'm not even talking fast. So you're now all basic ORM users. And now we can go to advanced ORM usage. ADV. And now it gets crazy. All right, so pick up where we left off. Column, integer, string, imports, declarative base. Same old user class, ID, name, and full name. The Reaper, so we can see them in output, table name. Now we will make another class. And this class will have a relationship to the first class. So, SQLAlchemy, this is again another place where we're kind of verbose. There's ways to make it less verbose. But in the usual case, this is where we're at. So every user in our database will have a list of 0 or more address objects. This is the same model that we have in the ORM tutorial on the site. You can, in this user address thing is all over the place. So the address, well, the user object has like the name, the full name. The address object has an email address field. So the user can have any number of email addresses. And in relational database world, we know that that means that address has to have a foreign key column that refers to the primary key column of the user. And you'll notice that while declarative, and all this stuff kind of automates a lot of the work for us, none of this, we haven't had anyone come up with an automatic primary key. Like, why do we have to type ID equals primary key? In fact, we don't have to call it ID. It could be called anything you want. It could be composite primary key. But SQLAlchemy doesn't assume that you're going to have a primary key called ID that's integer. It doesn't assume that, and it doesn't do that for you. And that's another place where we break from a lot of other ORMs, like Ruby's active record, and I think Django. Like, you don't type primary key columns in those ORMs. I mean, there might be some setting to change the name of the column or to do something, but those things just default the primary keys. And if you want to have two objects related to each other, you don't deal with the foreign keys. You just say, has many or something like that, right? And then those ORMs will just spit out all the columns and do all that work for you. SQLAlchemy doesn't do that stuff. Now, why don't we do that? Because I kind of wanted SQLAlchemy to be very appealing to data shops that already have databases in place, and data shops that already have conventions in place that don't match what SQLAlchemy does. Places where there's a lot of DBAs on board who think they think ORMs are horrific because they assume it means that their naming schemes and stuff are going to be decided. SQLAlchemy, very philosophically, because of where I used to work in Major League Baseball, really doesn't want you to ever think for 1 second that it's going to decide what your schema looks like. Because that's what people that are hardcore database geeks are afraid of, that the ORMs are just going to design your database for you. They're going to make all these stupid tables that you don't want. And they're right. Most ORMs, a lot of ORMs do that. And SQLAlchemy just really doesn't want to ever be mistaken for doing that. So it's out of the box really explicit about stuff like this. It's like, I'm not going to assume the name of the table. I'm not going to assume what the primary key looks like. I'm not going to assume what the foreign key looks like. I am not doing any of that for you. Now, in the recent years, we have come up with many, many ways to automate these things. Like, if you want all your classes to have certain table names, certain kinds of primary keys, certain kinds of constraints, everything, all of that can be customized. You can, and it's not customized by saying, like, just some flag somewhere, name primary key is this. It's customized by, you can make mix-in classes and base classes that have various functions and callables that are triggered by events. And actually, the talk that I'm going to do on Saturday is going to talk about those conventions. I've talked about them before, and it's kind of how SQLAlchemy tries to have the best of both worlds, where it can, A, be totally agnostic of how your schema looks, and B, still allow someone running a significant application to be saved from having all this boilerplate of all their columns. All their tables have ID columns and certain columns. All that can be automated. But it's automated through conventions that you make yourself. And that's kind of our answer to why we look a little more verbose out of the box. This mapping of the user address, I can reduce it down to like 2 lines with convention-based mix-ins and other stuff. The way it is out of the box, it's kind of like someone using SQLAlchemy is assumed that they know what their schema looks like and how it's going to look. And if they want to automate further, that option is available. So that's our stake in the ground with the ORM. So that's why you see here that there's a primary key ID on both the user and address tables. There's a user ID foreign key column referring to how the address table refers to the user table. And then on top of that, there's another attribute here, which is new, which is user equals relationship to the user class. And there's also this directive called backref, which means that the user class will have a collection of addresses attached to it. So you'll have address.user and user.addresses. So the ORM, out of the box, this can be automated, has you declare the way the two classes are related separately from the way the two tables are related. That's how it works. So it's 2 lines instead of 1. So let's see what happens when we work with this mapping. Create the tables, get the primary keys, foreign keys. So again, we'll add a bunch of user objects to get started. And probably going to, okay. So we'll make another user object to kind of look at what happens. So we create a new user with these attributes. And as before, the user object has this .id that was none to start with. It also will now have this collection called addresses, which by default is a Python list, and it is empty. So the reason jack.addresses is there is because we did this right here. That's where that comes from. Now, here's another thing. SQLAlchemy, you notice if you've used other ORMs, usually you'll type has many or one to many or is collection or something like that. We didn't do that here. We just said relationship. And what SQLAlchemy did was it looked at the fact that there is one foreign key between the two tables and said, oh, well, address has the foreign key to user, so I guess that means that user is a many to one and addresses is a one to many. So that's the one saving grace of relationship, is that in very simple cases, relationship is very succinct. It just looks at the way the database is already structured in order to determine the direction of the relationship and the cardinality. And this also works really well when you reflect an existing table. You can reflect a whole bunch of tables, and we can figure out how the relationships should work. All right. So the addresses collection is empty. And this object is also what we call transient. Meaning it is not yet added to a session. When it gets added to a session, it'll be called pending. But before you add it, it's called transient.
So, transient is right after you create it.
Yeah.
Pending is when you attach to a session, the session hasn't executed yet, and then after it's executed, what we call
Persistent.
Thank you.
And there's also a fourth state called detached, which is not as general use. Detached means it was persistent, then you close the session. So the object still represents a row in some transaction that's now over, or it's been evicted. And that's less of a day-to-day pattern. So let's take that addresses collection and add email addresses to this. We can say the addresses was already a list. We could say addresses.append if we want to, or you can reassign a new list, or you can say .extend. You can do anything that the Python list offers to make this collection bigger. You can replace it, it doesn't matter. And as we do that, and the Jack object is still transient, the fact that we made the relationship with as address.user with a backref to user.addresses, this behavior of what's known as the backref happened, which means that in memory, SQLAlchemy is going to kind of synchronize the collection in both directions. So meaning the Jack object has these addresses in it. It has 1, 2, 3. Each of these 3 address objects has a .user that refers back to the Jack object. And this is not in the database, this is just in Python. So to this level, the SQLAlchemy ORM is acting a little bit like a little object management tool. It's got some object management stuff going on. The way this works is that when you change the attributes on an object that's mapped, there's all kinds of events that you can catch. You can catch like the append event. So the backgraph basically catches the append event. It intercepts that you're appending an address and says, oh, as this address is appended, let's also attach address.user back to the object that's being appended to. And it works the other way too. And this is a very handy feature. And then the next thing is that the Jack collection, the addresses collection has 3 addresses. We can just add just the top level object to the session, and then all 4 objects will be added to the session in one shot. And that is called the save update cascade. Meaning, you have an object, you add to the session, SQLAlchemy will traverse all of the attributes that refer to other mappings. It'll descend into those recursively and pull all those objects out and put them in the session also, and it'll keep going all the way down. So if you have this big bunch of objects where there's this one lead object, like a document object, the document's got nodes, and the nodes have attributes and whatever, you just add the document object to the session, and then the whole thing will just cascade in. And the whole thing will be pending, and then when you flush it, all those rows will be inserted. And that's where the thing starts to save you a lot of time. You're not doing .save, .save, .save. It's just the whole entire thing goes in at once. So in commit, we get that whole thing in one shot. So you can see what's happening here is we're working with objects and collections, and we're really not thinking too much about SQL at all. And a lot of SQL is happening. There's a lot, I mean, so this is where unit of work had to do more work than before. Not only did it insert the rows, we're also dealing with auto-incrementing primary keys. You'll notice there's no primary key, there's no ID equals 1 here. SQLite database, like all databases, gives us a way to determine what the last inserted primary key was. So what it had to do is it inserted the user row with name, full name, it got the row, it asked SQLite, hey SQLite, what was the primary key of this row, by the way? And SQLite said it was number 5. And then the unit of work had to say, okay, let me take that number 5 and let me stick it in this row, or these other 3 rows here, before I insert those. So that's what ORMs do for you. They do stuff like that. They will synchronize the values of primary keys into corresponding foreign key columns. And that's where a lot of time starts getting saved versus not using the ORM. Like if you're writing an app and you have to do that by hand, it's kind of tedious. You got to get the primary key and put in the foreign key. This is where ORMs can save you time. More on the persistence side. Everyone's like, ORMs, and they talk about querying. It's really the persistence side that ORMs really save you a lot of time. Being able to persist stuff and all the synchronization of data that's required. So we committed the transaction, and remember that means that all of the state goes away. Everything is expired. So Jack addresses is gone. If we hit it again, the same dance begins. We get the implicit begin. We resuscitate the Jack user itself, and then we get the addresses collection, from a lazy load, and we get everything back again. And now that collection is cached in memory again. Yeah. You mean like descending, right? Yeah, that's coming. that's the you use something called eager loading. So we should get to eager loading right at the end. Yeah, there's a way you can either do a join, or you can do a second query that kind of gets all these results as one for each. You'll see it. You'll see. Yeah, that's obviously the other problem that ORMs have to solve is the n+1 problem. Okay, so the collection stays in memory. So if we hit Jack addresses again, there's no SQL. This is also a place where SQLAlchemy is different from a lot of other ORMs. A lot of other ORMs do not have persistent collections. They will hit the database every time you do this. We don't. We have it cached. We have an option. If you want to have a collection that queries every time, we do have that, but that's an option. Yep.
So I don't understand what transaction we're in the middle of right now. Because I guess I thought that the commit that we did in slide 9 was the end of the transaction. So did the transaction implicitly open?
It did, yes.
Okay.
That's what the session does. So the session commits, and when you commit, now it's at a dormant state. And then as soon as you begin working with it again,
Such as by querying.
yes. Yes.
implicit?
In practice, I mean, most people are running web apps. Usually when the session's committed, you're pretty much done with it. In practice, people usually commit the session, then close it. The pattern of having multiple commits within a session, you can use that. It's not that common. Usually, you just open the session and do just a single transaction. But you can, so it's not as common. It depends on how you write your app. Your average web application, there's just one transaction per request, and then you close the session, and it's gone. So that the whole expire and commit is not always a problem. But yeah, the session is implicit in that way, and it now it has another mode of operation where it has this, you can actually call begin on it. If you configure the session in what's called auto commit mode, it will be an auto commit to start with, and you can query. It'll do ad hoc connectivity for each query, and then you can say session dot begin, and now it's back in that state. And then you say commit, and then the transaction will be over, and it'll be back in auto commit. Now, the way it should really work is that there should not be, well, it probably should work the way it works. But another way that it could have worked would be that you make the session and it's dormant. You're not allowed to call anything until you say begin. Right.
Very explicitly say, I am aware of transaction as SQL.
Right. You could. So that's another way. It could have been like you say begin, and now you're definitely in the transaction. Then you say commit. Now it's over. Now it's an error to use the session at all until you say begin again.
So in the state that we're in currently, right now it's at 11, what could I do to actually say I don't want to be in a transaction right now?
You'd have to either commit or roll back. There's no other option, right?
Right. So there doesn't seem to be anything to commit, so I would just sort of issue an empty commit.
Well, okay.
Actually made the changes since the last.
Right. So what I normally do, so that's the thing, is that if you only did selects, why would you want to commit anything? Right. That's true. If you only did selects, you could roll back and it's the same. It's just it's the same. If you just close the session, there's a close method. That will actually just get rid of the connection and return it back, and that will actually result in a rollback as well. So I tend to, if you don't care about the transaction, I would just say you close the session, and then whether it commits or rolls back is then handled by the connection pool, because there actually are people and implementations where they want every transaction to commit, even if it's just selects. There's some SQL Server shops where they have some kind of issue where they need it to commit every time, even though there's nothing. I think it has to do with the query caching. I don't know. So yeah, it's actually not a straight cut and dry that what people want it to do when you close out. So yeah, what I do when I write a web app is I have the web method will open a session, do stuff with it, and then just close it. And then on those very few methods that are like post, where I actually want to persist, I'll do the commit right there, or I'll put a decorator like commit session. And otherwise, I don't commit or rollback. I just close it, and then the connection pool takes over the commit or rollback of the connection, or closing the connection. It's connection pooling. I didn't get too deeply into connection pooling. SQLAlchemy, the engine, is pooling the connections. You don't have to pool connections. You can have it such that when you connect, it makes a brand new connection, and then you're done. It closes the connection. You can do that too. There's usually not, but the thing is, if you're using a connection pool, and you work with a connection, and then you're done with it, you put it back in the pool. You want to definitely make sure at least rollback was called on it, because the connection could have state in it that wasn't committed. It could have locks on tables that you want to roll back. So the connection pool, when you return a connection to the pool, at the very least has to roll it back, or commit it if you did something with it, or it'll, depending on how things are working, it might close the connection. If it's like overflow connection, it might just close it out totally. When you close the connection, that typically will roll back the transaction as well. That's how that goes. What is this slide talking about? Right. So you can't. So this says that collections are updated by manipulating objects and not primary foreign key values. You can manipulate foreign key. Like I could say some address dot user ID equals 5 and flush, and that would be fine. That would be totally fine. You can do that, and you might want to do that. But the ORM in that case won't know that something changed as far as the collections. So the ORM tends to work smoother if you want to move things around. You want to get a different user object, and you want to take one of the addresses, and change it to talk to a different user, it's easier to work with just to not, like you might say, hey, what I need to do here is change the user ID of this address object to point to the Fred ID. That's really what this is going to do. You could do that, but then that wouldn't, SQLAlchemy wouldn't know that that should modify the Fred.addresses collection. It wouldn't know that the address.user should change. So it works better when you work from the point of view of just move the objects around, just point them to who they point to. Just put the collections and the references as you want, and let SQLAlchemy handle the fact that there's a foreign key column changing. Does that make sense? So you can work both ways, but SQLAlchemy is opinionated. It wants you to work in that direction. And so there are people that are like, no, I really, really have to do the user ID myself. And I've come up with some recipes that allow you to track this, changing that directly with an event that'll do that. But I've really avoided making that a first-class feature because I can't answer you. The ORM has to be somewhat opinionated, otherwise it'll get like just all over the place. So it kind of wants you to work in that direction. You don't really have to, but things will go easier if you do. Okay, so here's what it all comes down to, is now we have two tables and there's a relationship between each other. The core slides didn't get into this because the SQL advanced slides will get into this, but I figured let's just do it once. Doing queries that are with more than one table. Joins, which is a whole can of wax. Where's that? Can of worms. What's the one with wax in it? Ball of wax. All right. So an implicit join is if you just select a bunch of columns, and then the from list has two tables in it with a comma. And then you say select star from this comma that. And if you don't have this where, you'll get something called a Cartesian product, which means you'll get every combination of every row. So you take the two from clauses and make sure that you get just the rows that match up by aligning the user ID with the address user ID, and you get back user and address entities matched up. You get the user Jack with the one address, then you get the Fred with the one address, and then you get another Jack with another address. So you get three rows back total with the two users, and also knows that this user object is the same identity is the same object as this user object, because that's the identity map. So within one result set, we have the same object twice. So that's an implicit join, which means that we didn't use the word join. So if you want an explicit join, at the very simple level, you can just say, hey, query for user address, join to the address on that on clause. Now, a join is between two tables. The convention here, there's a convention here, is that join will by default look at the first entry in the list as the left side of the join. So this is going to be join from user to address with that on clause. And so you get the same exact query, the same result, but instead of from user comma address where, you get from user join address on, same thing. So far, so good. Now, you can use the relationship. This is, again, querying in terms of the object model to say user.addresses. And that's also the same thing. It knows, join knows what user.addresses means. It means to join from user to address. So here's where relationship helps us. And you can also do this. A lot of people do this. I don't like it as much. It's a little more error prone in some ways. You could just say join to address. This pattern will actually look at the foreign keys between the tables and figure out how to join. So SQLAlchemy does a lot of stuff in terms of, hey, can we figure out how to join between these two entities unambiguously? If there's any ambiguity in how to join to those two things, like two foreign keys, it'll give up. You'll have to be more explicit. It will only do the join when there's no ambiguity. So when you join, if you want to get like usernames and join to addresses and then filter on email addresses that is that address, You can just refer to those entities anywhere you want freely. You get that. And if you wanted to join from the second entity to user the other way around, you can say select from. So we have user address, but no, select from address first, and then join to user. You get that. Getting more crazy. You know when you work in SQL and if you want to refer to the same table more than once in a query, right? You say select from table as X or Y, right? The equivalent to that in the ORM is the aliased construct. So you apply alias to your entity that you want to alias. Now you see here is where SQLAlchemy, the ORM is not hiding this detail of SQL or relational algebra at all. You totally have to know what a join is. The fact that if you want to join to the same table twice, you need to alias it. That's all exposed. There's no way around that. We make these two aliases. We query from user rows. We join first to the first alias, which will figure out the on clause. We join to the second alias, which will also figure out the on clause. We filter the first one on this email address. We filter the second one on that email address. And what we'll get are users who have both of these addresses at the same time. Right? So you get a bigger query. You get select users from user join address as address 1, join user as join to address as address 2. So you can see here what happened is we didn't actually create this name address 1 and address 2. Those are called anonymous aliases. But just by saying alias address, SQLAlchemy knows it has to come up with a name, and it will keep track of that name within the query. We don't have to worry about it. We just worry about, we don't want to worry about names of things. We want to worry about the objects. We have this A1, A2, or aliases. We deal with those. We don't deal with the names. We get back that. And then to get really crazy, I want to get to the eager loading, so you show you that. Subqueries. This is a crazy query here. What are we doing? We are querying using group by. Ooh. We're getting how many address IDs exist per user ID. And actually, this query is a little unnecessary because we can actually group by address.userid. We don't need to actually join to user here, but I would assume this is written this way just to look fancy and look like, look what you can do with SQLAlchemy. So suppose we had a join to this other table to group. So we have this query, and we're going to do this. Func is a core construct that lets you do any SQL function like count, max, min, average, sum, all that stuff. Func.count will give us a count function. Count the address IDs. Label the column as this is just more stuff that you'd be looking at the docs. So this is just label as count. User label get user ID is labeled as user ID, and then we make this into something called a subquery. And what happened here is that this query, which is an ORM query, became back into the core select world. It became a select object again. This part is going too fast, but the point is it became a select object that we can now refer to as a table. Like if you have a subquery in SQL, the subquery has columns in it just like a table does. SQLAlchemy has that same concept. So this example, which you can just, I mean, if it doesn't make sense, it's a little more complicated. The point is subq suddenly gets, when we say subquery, gets a .c collection on it, and now it can act like a table in its own right. Maybe if I just show you what it does. so that will, and then we have some more functions just to make it even more crazy. The coalesce is basically if the count is null, it'll give you 0 instead. It's because we're doing an outer join. So complicated. So anyway, the point is a session query, username, and then some function, and then it's going to do left outer join, because that's what outer join does, to this subquery in parentheses over there. Also has an anonymous name. So this is where, this is a little more crazy stuff. That's a fancy query. Yeah. Yeah. It will render the order by clause as you told it to in the subquery, but that doesn't necessarily mean that the ordering of the outer query will be in the same order, because it depends on most databases probably will order it. Oracle definitely won't. Oracle gets totally. It depends on how the query optimizer works. So if you order on the inner subquery, you can't really count on that propagating outwards. You'd have to order on the outside. And SQLAlchemy doesn't try to make any kind of guess about that. It doesn't try to guess that you want to move it out. We're going to skip this exercise because I just want to show you some eager loading stuff. All right, so this is the n+1 problem that you asked about. So this is where you're going to load all the users, and then for every user, you're going to load all their addresses, right? So we're going to say select start from user, 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 and then for each user, we want to see the addresses collection. It's going to be, select start from addresses where user ID equals 1, user ID equals 2, and you get this, which is a lot of SQL, and they call this the n+1 problem, which means that we have, say, 5 user rows, and we want to get all 5 user rows and all their collections. We get 6 queries. If it was 5, that was a number. We get the first query for just the user rows. Then for each row, we get a second query. So that's a big problem with ORMs, is that you might do this very innocent code. This is so simple. This is such an easy, simple thing, and I get all that query. So this is like every anti-ORM article starts with this. This is the only argument they have. It's all they have. n+1 problem. It is a problem. It's true. It's true. If that the ORM makes things look simple that actually are hard. So what we say is you need to make sure your app is not doing this when you don't want it to. You have to look at this. The SQLAlchemy makes it very easy to see the SQL. Most ORMs don't make it that easy. They make it really difficult to see what it's doing. We make it super, super easy. You should be watching. And then you basically apply an option to your query, knowing that you will need, you apply an upfront option. This will say, hey, load the users, but then load all the address collections in one shot with one big query. And then we get 2 queries. We get the first query that we asked for, and then we get this thing, which basically gets all the collections at once. It takes the query that we did and puts it inside of a subquery, and then joins the whole thing. There's some other variants on subquery load that we might be adding that are even more efficient than this, that will actually do an in. That's a different subject. Another flavor of eager loading is joined load, which will use a left outer join to make it just one query. The trade-off here is that you get a lot. If you have a very nested structure, you might have a lot of rows that you don't want to get. And you have a lot of extra columns that you're reading for no reason. Join load is pretty good for eager loading a many to one if we had addresses and we wanted to eager load the user. So that's join load. But the point is, the query is separate from the eager option. The eager loading option does not change the result of the query. That's the whole idea of eager loading, is that you query for user with your filter criterion. You can put whatever you want in options, and the results of the query will not change. Only the way it loads the collections will change. And there you go. Here's me anticipating the slide. Eager loading does not change the result of the query. Only how the related collections load. So if we load for address and address, join a user, we can join load and get that, and I'm assuming it's going to change the right. So yeah, so it just loads the same no matter what you do. So if you want to actually do an explicit join that you need to filter on stuff, and you also want that to be the thing that is eagerly loaded. Oh, let me see. Yeah, I know what that query is about. Sorry. What this slide is showing you is that when you do address join to user, and then you also do a joined load, it joins twice. That's the point of this slide. Is that it's going to first join, because we said join, and then you see that this big left outer join, which is the joined load. So it's twice. So one of the joins is just to get the row that we want, and the other join is to get the user row. And that's kind of wasteful, because this inner join and that outer join are really not changing the result at all. So if we want to optimize this such that this one join can be reused, we can use contains eager. Again, this is only introductory. There's a really good chapter in the docs that you could read through that will go through all this exact same stuff all over again. This is just the intro. And I think we're just about done. We're probably on the last slide. A huge exercise, which we're going to skip. But this is basically the final exam, and this is a take-home. In my inbox tomorrow morning. So, yeah. There was everyone got the survey link that we put up before. Let me see if I can. Survey. So if you can all go to this link, they want you to fill it. These are the same links. They want you to do the survey for the tutorial sessions. Yes. Alembic. 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 Wow, you haven't been in Python in a long time. Alembic. You haven't heard of it?
No, I never heard of that.
This is I know Shannon, and he's. It's called Alembic.
Like the beer?
No, it's here. Alembic. Yeah. Like Alembic guitars, was that?
It's like there's beers that are like that, right?
Maybe, yeah. I think alembic, it actually means it was some kind of alchemical substance that would modify the gold to something else. So it's for schema migrations.
So it's interesting that you named your software after a disproven methodology.
Who said it's disproven? Who says? It's under development. It's not version 1.0 yet.
Like, is that what it takes to get to
You know what it was? SQLAlchemy, we didn't used to have the query object. We had just the mapper, and you would query from the mapper. And I really imagined it to have a lot of, that people that use this would be able to do very amazing things with a lot of trial and error. Like I pictured it as very componentized and like really, it's kind of discombobulated when you start, and you really have to figure out how to get this thing. And then all of a sudden it's like, wow, that's amazing. So for that, I kind of had in mind the image of the alchemist blowing up his house 100 times until he gets the gold.
turning the lead of SQL into Python?
Yeah, sure. Very good. Yeah, you can go, yeah, you can take it many places. Yeah. Oh, is this the sign-in sheet? I thought this was the. I have this paper. Is this what you need? Does this affect something? I don't know what that really means. Okay. Thank you. There's some conventional, some changes to things that raise warnings now that'll become exceptions, and I don't want 1.0 to have too many dramatic things in it. I'd have to look at. There's a timeline that has the stuff. There's not much, but usually over the course of the year, a lot of stuff will be added. By next year, I'll have thought of 10 more things. It always happens that way. Yeah.